Hello and welcome to ZaranTech. Did you know that software defects cost the global economy $1.7 trillion annually? This staggering figure underscores the critical importance of quality assurance, QA, manual testing in today's digital age. QA manual testing involves the systematic process of verifying and validating software applications to ensure they meet quality standards before release. It's a hands-on approach where testers meticulously run through scenarios, checking for bugs and ensuring functionality aligns with user expectations. Effective QA practices save costs by preventing up to $100 for every dollar invested, enhancing product quality and bolstering user satisfaction. Manual QA testing ensures seamless user experiences, reduces post-release issues, and builds consumer trust by catching defects early and boosting software reliability. In this series, we will explore essential QA manual testing principles, test planning, execution strategies, and detailed reporting. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now let us look at the agenda. 1. Software testing concepts. 2. Introduction to testing concepts. 3. Methods of testing. 4. Performance testing techniques. 5. Identify scenario-based test cases. Let's dive in.
So, the first topic is what is software testing, right? So, basically, we have there are so many things in the software testing. So, we'll start from the basic. Like in the software testing, basically, we are evaluating the functionality of the software application or any kind of website or any kind of mobile apps to find the software works. Like if we are going to use as a any application as a user, so if we found the bugs in that, it is not good for the any company or like this. So that's why the QA is doing the testing so that a user can use application without any issues. And the second thing is basically it checks whether the developed software, whatever the application is, it has met the specific requirements and identify the defects if the application is using. So it will be like improve the quality of the software. So it basically its main role of the QA is to identify the bugs and to check whether the requirements are met or not, so that a user can able to use a very good in a good way, in a good manner. And then it's basically executing a system in order to identify any gaps, any errors, or any missing requirements to the actual requirements. So in the software testing, we have two steps. Like one is verification, and the second is validation. So basically, it states the process of verifying and validating a software product. It also checks like if we meet the business and technical requirements that guided its design and development. And also, we are working as per the requirement, whatever requirements we have as per the BA or product owners or business analysis. So we are working as per the requirements, and then we can implement with the same characteristic in a same manner. So next point is like why do we need software testing? Why companies are hiring QA? Why there are so many QAs in our IT companies and all? So first is cost effective, because if developer are working and if developer are not doing any major testing or any kind of testing, it does like just implement the things and just go ahead. So basically, that's why they hired QA, and just because of cost effective, just because of security, just because of product quality. Our main concern is product quality. And then and last one is customer satisfaction. If company get the satisfaction from a customer, that is the only way a company can grow. Otherwise, there is no use to work on the application. So, what are the principles of software testing? Right. So first one is software testing can help in detecting bugs. It basically, if we are working, so basically we are just identifying the bugs in the application. So basically we are talking about the principles of software testing. So first point is it can help in detecting the bugs, and another one is like it is effectiveness is impossible. Like if you're working with the if we are doing the testing, then if it's very effectiveness, and it will be a early testing if we are going to release. So we are doing the testing in the early phases. And the next one is it will be defect in a clustering. And then there's software testing is basically a context dependent, and it's a error free or bug free. So next slide is what are defects, bug, and errors. So basically, what are the difference in both in the defects and bugs? So an error is a mistake made by human that leads to discrepancy between the actual and the expected result. And a defect is a problem in the functioning of a software system during testing, and a bug is a flaw in a software system that causes a system to behave in a unintended manner, right? So next slide is what is software quality. So the software quality is a conformance of the software system to its requirements, and in the software perspective, quality is ensured by two sets of activities. One is validation and verification, which we have discussed earlier. So the attributes of the software quality is correctness, reliability, robustness, usability, portability, and efficiency. So this is all the things which we are considering for the introduction of a software testing. Okay, so now in the second module, we'll start with the SDLC. Basically, it's a software development life cycle. So in this, the first phase is requirement analysis. Second one is design. Third one is implementation, and then testing, and then evolution, or we can say that release. So what are the advantages of HDLC? So basically the outcome of this process will be associated with the qualitative model with the and the disadvantages is we need a lot of planning for this, and also it will impact the cost and monitoring. So the feasible studies, if the analyst conduct an initial study of the problem, so the first one is like technologically possible and economically possible, and then legally possible. So analysis is like we are doing analysis on the basis of some documents like SRS, software requirement, and BRS, URS, FSD. So these are the requirements. These are the documents which we are considering while analysis the requirements. The next one is design. So if we move to the next phase after analysis, so in that we are considering some attributes like what kind of user interface it's required, the designs, the screens, what is the HLD, high level design, and low level design, user interface, like this. So our next part is coding, which we are implementing the requirements. So in the coding phase, we are working with the program coding like languages or like source codes. So next phase is delivery or maintenance. So if once the implementation is complete, then we'll move to the installation of the software, or we'll go with the testing, we'll go with the maintenance after the uh, deployment is done, after the application is done. So what are the SDLC models? So first one is waterfall model. So in the waterfall model, we'll start with the analysis, then go with the design, then coding, then testing, and then maintenance. It's a waterfall model. So waterfall model can be chosen by the organization when the project size is small or user requirements are constant. So all the stages we can implement in the sequential process. So the advantages of the waterfall model is it is fit for the small projects, and the disadvantages are it is a time consuming model. It doesn't support for the large product projects, and it doesn't allow any changes from the middle of the process. So second is prototype model. This model can be chosen by the organization when the project size is small and the user requirements are variable. And another point is user have the review facility in only the analysis stage, not after that. So prototype model is like when we are doing the analysis or requirement gathering, then we'll go with the build prototype and then testing and then user. And then after that user, we are just, if we get the change requirement, then we'll go to the change requirement and then prototype and test, and we'll do the testing for the and then user. So after that, in the last thing, we are designing the application, then coding, then testing, and then uh, give it to the user. So the advantages of prototype models are it allows from the user in analysis state. Like we can do the changes from the user in analysis stage, and the user can have the review facility. And the disadvantages are it is a time consuming model, it doesn't support for the large projects, and it is a costly to implement. So another model is iterative and incremental model. So this model can be chosen by the organization when the project size is large and the user requirements are variable, not constant. Okay, so variables like some requirements are getting early in the early stage, or some requirements are getting in the after the requirement. So in this model, we can complete the entire project with respect to modules or versions. So the advantages of this model are it is very easy to maintain the project. It is suitable for large projects. It allows changes in the middle of the process, and the user can have the review facility at the end of the every module. So once the module is completed, so user can review the facility or implementation. And the disadvantages are it is a time-consuming model and it's costly to implement. So the another model is a fish model. In the fish model, basically we are deployment or release. We are requirement the gathering phase, and then coding, then analysis, and then project initiation. So the advantages of fish model is it's easy to implement, and every stage of this model is tested by a separate team for completeness and correctness of application. So basically, it provides a high quality software product, and also it provides full documentation of the application, and it is mostly used for secured and complex projects. So the disadvantages are in the model, the review and testing start from the project initiation node to the maintenance phase. Due to this reason, the fish model is a costly for development. And the second one is similarly, it is a time consuming process to develop the product. And this model is not preferred for a small project. It is an expensive model. So the development failure will cause a lot of damage and loss. The risk are not identified at the initial stage, so we can't prevent it, and we can't change the requirements in the middle of the process. So once we start the implementation, so we can't change the requirement if we get anything from the user. So the next model is V model. So in the V model is first we are getting the requirement specifications, like, and then high level design, then detailed design, then program specification. So these are the things we are considering in the verification, and then unit testing, then integration, then system, and then user acceptance. So these are the kind of validations. The advantages of V model is emphasize for verification and validation of the product in the early stage of the product development. Each stage is testable, which is good in the V model, and the project management can track progress of milestones, and then easy to understand, implement, and use. And the disadvantages of V model is it doesn't easily handle events concurrently, it doesn't handle iteration of phases, and it doesn't easily handle dynamic changes in the requirements, and also it doesn't contain risk analysis or mitigation activities. So these are the models we have in the software develop, which we are using for in the software development lifecycle.
Okay, so all these models, they're like soft, they're SDLC models, right?
Yep.
Okay, and which one is used the most, or no, it's not one that is the best, or?
Basically, right now we are using maximum like small companies are using a waterfall model, but
what about the large projects?
So basically, for big projects, companies are using a agile model.
Which one?
Agile. So basically, in the agile, we are just using the iterations in the every phase or in the every requirements.
All right, let's test your knowledge. Here's a question for you. Which of the following is an advantage of manual testing? Option A, faster execution of tests. Option B, easier to identify user interface issues. Option C, requires less human involvement. Option D, consistent and repeatable results. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
So the today module is related to testing techniques, which we have we have multiple testing types. So we'll discuss about the types of testing and test techniques. So we have 5 types of testing techniques. One is a BVA, which is called as a boundary value analysis. Second one is ECP. ECP is all about equivalence class partitioning. Third one is decision table, and fourth one is state transition, and the last one is use case. So we'll discuss one by one of the testing. So there are one more thing, a white box testing types, which is like statement testing, branch, decision, and cyclomatic.
Wait, this one, white box testing, it's another technique besides all these 5? Or
yes.
Can you go, please? Can you go back to the fourth? Yeah, here, use case testing techniques. Okay.
So we'll start from the ECP, like equivalence class partitioning. So equivalence class partitioning is all about it basically convert the huge data into finite numbers of partitionings. Like it allows you to divide the set of test conditions, or we can say that we have some components in ECP like requirement number, requirement name, conditions, what are conditions we needed, valid partitioning, valid types, invalid tags, and expected data. So first of all, we'll go through the SRS document for ECP, and we'll understand the requirement given in the SRS. SRS is called Software Requirement Specification. So in the SRS, we can find the partitions of the applications or the requirements. So first of all, we'll identify the valid partitions, and then we'll identify the invalid, and then we can prepare the data as per the valid and invalid partitions, and we'll prepare the test cases or data for this. So for example, like if we have some values like 1 to 10 or 20 to 30, so 0 to or like infinite to 0, which is called invalid, and then 1 to 10, like if we go with the valid value, which is 1 to 10, it's a valid value. And if we go after the 30, so it will invalid. So for the example, another example is if we go like the requirement is mentioned, if the age is between 0 to 16, so the organization rule is we can't hire that person. If the age is between 16 to 18, we can hire, but as a part-time only. So, and if we go with the 18 to 55, we can hire as a full-time, and after 55 till 99, so we cannot hire. So these are the criteria, these are the rules for the ECP or like this. So first of all, if we define like this, like if applicant type is 0, 1, 14, 15, so we cannot think like a developer can write the code in this way because it's a very long code. So in this, we can use the minimum and maximum conditions in the code. So in this partitioning, we can start with the test cases, like whatever test cases we have as per the rules. So we can create the test cases like test case 1. If we go with this, test case 1 is if the age is 0 to 16, so the expected behavior is we cannot hire. The test case 2 is if the age between 16 to 18, so we can hire for a part-time. So these are the test cases we can create for ECP. Yeah, any doubt in the ECP, equivalence class partitioning?
When you say test 1, test 2, test this one, test case 1, test case 2, so test case 1 would be the 0 to 16 that we cannot hire. Is that am I
right? So these are some test cases. So next topic is next testing type is BVA, which is called as boundary value analysis. So in this boundary value analysis is based on the boundaries between the partitions. So we have some components, same components which we have in the ECP. It's like requirement number, name, conditions, valid boundary values, invalid boundary values, tags, expected data. So these are the components in the BVA. So first example is like if applicant age is 16 years, so it should be like hired or not. Are you able to see the first condition? If applicant is more than 0 and less than 16, so what is the test case for this? Like we can hire or not? Okay, so as per the rule 1, we cannot hire because the applicant age is less than 16. But if in the same second condition, if you can see the applicant age is more than 16 but less than 18. So this is the rule 2. we can hire, but on the part-time basis. So we'll start with the basic form. So we have some components, so we have some fees like name, account number, loan amount, term of loan, and monthly repayment. So the name rule is minimum 2 characters and maximum 64 characters. Okay, so how we can test this for a name field? So as per the boundary value analysis, we can test on the boundaries. Like we'll start from 0 or minus values to 2, which is invalid, and then we'll test with the valid tags or valid values like 2 to 64, and then again we'll test with the invalid values like more than 64. So these are the test cases for name we'll create, and same for account number. The rule is mentioned that only 6 digit and 1 digit first digit should be non-zero. So only 6 digit is like 1, 2, 3, 4, 5, 6, and we cannot use zero from the starting. So if we go with the account number for testing, so first of all we'll start with the 1 digit, 2, 3, 4, 5, and then 6. And also we can test with the zero values starting from the first digit. Got my point? So boundaries basically whatever the rule has been explained, whatever the rule has been designed. So we'll test before the values and after the values. If we go with the loan amount requested field, so how we can test? The rule is given 500 to 9,000. Yes, we'll start with the less than 500.
Less than 500 and not more
And
than 9,000. But how do I know how to say that?
yes, yes. So we'll start with the less than 500 first of all. So we'll test with the less than 500 values, like 300. We'll check with $300. So and once we submit, so it is showing that it's invalid. It should be between 500 to 9,000. Got my point? We have a rule for loan amount which is mentioned 5,000 to 9,000. So if we enter the value between the $500 to $9,000, so if we enter the values between this and click on submit, so the value should be validated and it's a valid value. But if we enter the value below 500 or more than 9,000 and click on submit, so it will not allow to enter, or it will not allow to redirect to another page because the rule is failing or the validation is failing.
I think I get it now. So less than 500, more than 9,000.
Yes. So the next field is term of loan. So the term of loan is, the rule is defined 1 to 30. So can you explain like how we can test this?
So we can, if we put a value less than 1, right?
Mm-hmm.
And then same as the last ones, more than 30 years. So if it's a value higher than 30, right?
Yes, so it will not allow the application, it's not allowing to submit or like not allowing to redirect to another page because the value is invalid. And another field is monthly payment. The same will test minimum $10. So if we enter minimum 10, exception or the validation should be there to enter minimum 10. So this is a thing we have already discussed, like valid partition. Valid rule is um, 2 to 64 characters, but we check some invalid partitions like less than 2 characters or more than 64 characters for name field. Same account number which we have already discussed.
Okay.
Loan amount is done. Condition template. 1 second. So it's a condition template which we have already discussed for customer name, account number, loan amount, what is the valid partitions, what are the invalid partitions and all. So The next type is decision table. So basically, decision table is used to define critical business rules to the system, and we can prepare to test cases for all the possible combinations. So the components are conditions, actions, and rules. So the same, first of all, we need to check the SRS document, and then we need to identify the possible combinations or possible conditions from the SRS. Then we need to find the rules using the formula, and we need to identify the actions, then prepare the test cases for the decision table. Basically, we can use decision table for functions which respond to a combination of inputs or events. Like a submit button should be like any kind of button, login, submit button should be enabled, should be enabled once all the field are validated. So like if we have a first name, like if we go with the example of this, if we enter the name in between the 2 to 64, or we can enter the account number, loan amount, term of loan, and monthly payment. If we enter all the amount in the field with the valid tags and click on submit, then it should be enabled and it should be redirected to the another page. So this is the thing which we doing in the decision table. So in the decision table, we are creating some rules as per the conditions. So every rule has a minimum one conditions. So for the example, like we are testing an insurance system to be used for making decisions about whether policy can be granted to a customer or not, and accordingly, what discount should be given to the customer. So the conditions are the user can be married. Okay. The second condition is the user can drink or not, and the another condition is good student. So we have some rules like married. It can be yes, it can be no, it can be prefer not to disclose.
So the rules would mean like the options that they have, right? I mean, if it's married or not, like, so another word for rules would be options, or no? Just for me to
Rules,
understand.
yes, yes. Rules we can consider as a test case or a possible combinations. Like
Oh,
if we
possible
go,
combination. I like
yeah.
it. Okay.
So the input is married and the question mark is there. So first rule is it can be yes, or second rule is it can be a no. Like user can be a single, user can be a divorce, user can be a married. So these are the
Right.
test cases which we consider to test this.
Okay.
So the next type is state transition. So it is used to prepare the system internal designing, and also we can prepare the scenario based test cases. So we are going to prepare the scenario based test cases and some components of STD for state transitions and event and actions. So we'll explain about this in the next slide. The same criteria is there also. Like first of all, we need to understand the SRS. We need to identify the states. We need to identify the events. What are the actions in the SRS? Then we'll define or we'll draw the diagram, assign the numeric numbers, find the scenarios, and then prepare the test cases. So the example for STTA is like these are the requirements. When the ticket is printed, the system goes into once the ticket is print. Like if the airlines or if any of the company is printed the ticket, then the system goes into the another state, which is ticket generated. And second point is upon boarding the plane, the customer gives the boarding pass along with the ticket, which signals that a ticket has been used. So another requirement is if the reservation is not paid on time, like if we get a time for 24 hours, 48 hours, and if the pay timers expire and the reservation is cancelled for the non-payment. Another requirement is a reservation may become cancelled if the customer wants. Like if we have a reservation, if I want to cancel the reservation, so I can. So this can be happen either prior to the payment or after the payment. If after the payment a refund needs to be generated, a customer has to return. If the ticket is generated, in that case, customer has to return the ticket to the agent for refund. It's an example or diagram we can use for this. So first of all, I can explain the terms of the state, transition, event, and action. What is state? So state is a condition in which a system is waiting for one or more events. It is generally represented by the values of one or more variables within a system. In the diagrams, states are represented by circles. So if you can see, the circles are the events. Okay. So first of all, we'll discuss about the state. So state is defined, represented by circles. So what are the states? Like made, paid, cancelled, cancelled by customer, ticketed, used. So the circle ones are the states. The second one is transition. It represents a change from one state to another caused by an event. So in the diagram, transitions are represented by arrows. So first of all, these are the arrows like given info start pay timer, cancel pay time expires, pay money, printed ticket, cancel refund, cancel return ticket refund. So these are the transitions. Another version is event. So it is something that causes the system to change state in the diagram. Events are represented by labels. So event is if we go to the main, so start pay timer, it's an event. Another event is cancel, and another event is pay time expires, pay money, print ticket. These are the events. And the last one is action. It is an operation initiated because of state change. Action occurs on transition between the state. In the diagrams, actions are represented by the commands following the slash. So we have some slash in this. Give info or start pay timer, print ticket slash ticket, cancel either it can be a cancel or refund. It can be a cancel, return ticket or refund. So these are the components which we have used in the STD. So any doubt in this? For STD, it is an excellent tool to capture the certain types of system requirement and document internal system design. So it has been documented the events that come into and are processed by a system as well as the system response. Represent one specific entity at a time. It describes the state of an entity, the events that affect the entity, the transitions of the entity from one state to another, and actions that are initiated by the entity. So another example is, it is for you, Catalina. So the requirement is provide the information, including a departure and destination cities, dates, and times. So these are the requirements which mentioned in the diagram, or we need to create the diagram as per the requirements. So after this session, you can go through the these requirements. So next one is use case testing. So basically, use case is what? Use case is like to identify or to execute the functional requirement. So whatever the functional requirement mentioned in the SRAs, so we need to identify the only functional requirement, and we can create the test cases on the basis of the functional requirement. So the use case testing. is commonly based on typical scenarios from the receiver of a developed product. It is a purpose is to find defects by using the product in a way that it is used in the real world. Use case do not only describe the way that the product is likely to be used, but also describe the way that the process flow through the system. A use case also referred to as scenarios are valuable ways of finding defects associated with the integration. It is common for the use case to form part of acceptance test. So we'll explain the acceptances in the further slides or further session, and may have involvement from the customer or end user. However, it can be it is not useful for testing unless the descriptions are in place. So we are preparing for business scenarios. Basically, use case are using to prepare the business scenarios, and we have components to prepare like actor, action, and response. So these are the components which we are using in the use case testing. The first one is use case number or identifier. So in the description, it can be a unique identifier for every use case. And second one is name. The name should be the goal stated as a short active verb phrase. It can be a short name like. And the third one is primary actor. So the actor means like a role name or a description of a primary, like of description of the primary actor. And another one is preconditions, the required state of the system before the use case is triggered. Like if we are going to test any application or any module, so what are the preconditions? Like if a login page we need to test, so first of all, we can just preconditions are we need to go to like a form link, and the form link should be open, and if we need to check with this, so these are the preconditions. Like first we are going to some link, and then the link can be open with the valid field like this. So these are the preconditions. And the another one is success and conditions, the state of the system upon successful completion of this use case. And the failed success, basically expected behavior, we can say. Failed and condition, the state of the system if the use case cannot execute the completion. So if any test case is failed, so we can consider as a failed and condition. Another one is trigger, that action that initiate the execution of the use case. And the success scenario is we can mention many steps for a single test case, and what are the actions. Like it should be like this, it should be login, it should be validate, it should be valid tags, it should be valid values like this. So for use case diagram, the template, first scenario is we can consider basic flow. First, basic flow. Second one is basic flow plus alternate. Like a basic flow is we can enter the login ID, password, and submit. And in second scenario, we can use some alternate flows. Like if we can enter the username and click on submit, what is the expected behavior of this? And if we can enter the password only without any username, so what is the expected? And if we enter the invalid values in both the fields, what is expected? So these are the alternate flows and exceptional flows. So this use case is clear for you?
What do you mean by basic flow? What's that?
Basic flow is if we enter, like if we have a login page and there are some fields like login name and so username and password, and we have a submit button. So in the basic flow, we can check, just enter the name, enter a password, and submit. It's a basic flow.
Okay.
And
Okay.
if we need to test with the multiple flows, multiple test cases, because we can create multiple test cases for login page, like with the valid, with invalid, with without data, with data, like this. So these are the falling in the scenario 2 and scenario 3. Like another example is if you are testing any application, which is some fields like one second, I'll share some example with this. So this is a form, and now we need to test with the scenario 1. So what you can do? So the basic flow is basically the which we are entering the values, and once we enter the values, then click on submit. It's a basic flow. Like I have a form, I have some values like name, account number, and like this. So I'll go this on this page and just enter a name like Catalina, account number, loan amount, term of loan, monthly payment, and then submit.
So all my, like, let's just say credentials would be a basic flow.
Yes, a valid credentials, a valid data, which we can say. So what is a test scenarios? Test scenarios is basically a documentation of a use case. Okay. In other words, like we can describe an action the user may undertake with a website. Like if we are going to test or create the test cases for the use case, so first of all, we need to create a test scenarios. A test scenarios having multiple test cases. Yeah, like test scenario is we need to validate the login page or we need to validate the submit button. Okay. So in that we have multiple test cases. Like we can enter the first test case is like we can enter the valid credential and click on submit. Another test case is we can enter the invalid credentials and click on submit. Third test case is we cannot enter any value. We are not entering any values and click on submit. Another test case is we can will enter the username but not password and click on submit. So these are the test cases, and test scenario is we need to test the submit button. So on submit, what we can do is like how many test cases we can test, how many alternate flows we have, how many exceptional flows and of basic flows. So these are the things are considered in the test case. You can just go through the slides. So if you have any doubt, you can come up with your questions and I'll explain I'll resolve the query for you. And another, I have given the to create the diagram for STT.
So for the state transition diagram.
Yes, the requirements are already mentioned. So for reference, you can go with this diagram.
Okay, so I'll use those requirements, and I'm gonna try to create a diagram like this one from the state transition testing, right?
Yes, yes. So
Okay.
the STD is basically diagram is for make reservation, but the requirement is different, another different for departure and destination like this. So you can just go through and try to create the diagram with all the requirements for this. No worries, no worries. If you have any doubt, I can resolve your queries. If we go,
Okay.
if we go more slides or more modules, so it will be a mess for you because like there are so many things in the testing types. So just go through all the slides, which and also do some assignments which you have, and also create the diagrams for this and come up with the questions. I'll solve your queries.
Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
So today we'll discuss about the methods of testing. So we have 4 5 methods. One is conventional, unconventional, white box, black box, and gray box. So conventional testing is, it is a sort of testing in which the test engineers will check the developed application or its related parts are working according to the functional requirements, not from the coding phase of SDLC. So like in conventional, we are just checking as per the SRAs, as per the functional requirements which is mentioned in the SRAs. So whatever the things it's mentioned in the SRAs, it's implemented or not. SDLC is a software development lifecycle. If you remember, we have discussed in the second module. It's a requirement analysis and design, implementation, and all. So next is unconventional. So it is a sort of testing in which a QA people will check each and every role in the organization from the initial phase of SDLC to the end in order to check whether they are doing their work according to the company guidelines or not. So initial phase of SDLC is what? Like first phase of SDLC is requirement and design implementation. So in unconventional, we are testing from the starting, from the scratch, and checking like the implementation is adhere to the guidelines of the company or not. Another one is white box testing. White box is what like a software testing technique in which internal structure, design, and coding of software are tested to verify flow of input output and to improve design and usability and security. In this method, code is visible to testers, so it is also called clear box testing, open box, transparent, code based, and glass box. So a white box is like the uh, like we can test through the code, or mainly we can call it a mainly developers will do the white box testing because QA, most of the QAs are familiar with the code, but some QAs are not familiar with the coding. So in that, white box are doing by conducted by the developers mainly. Any question about the white box? So white box techniques are testing, branch testing, decision testing, and cyclomatic testing. So basically, white box is doing by the developers. Another one is black box. So black box testing is a form of software testing during which the functionality of an application is tested without looking at the code of internal structure, or any test which examines the interface of the application is considered black box testing. So in black box, we don't need a code. We just go through the application. We just go through the UI part. We just checking the functionality on the UI part. So if we are testing on UI part, that is called a black box. If we are testing the code, when like if we are testing in the code, that is called a white box. So you got my point. What is the like in the difference with black box and white box?
So a black box would be the first step and then the white box?
No, no, no. White box is the first step. White box is conducted by the developers. So once the application is deployed on the QA environment or in the UAT environment or production environment, then black box testing will perform.
Okay.
Black box mainly conducted by QA and white box mainly conducted by a developer.
Oh, so white box is connected to the developer, right? You just
Yes,
said that, right? And the black box to the QA.
yes, yes. In a white box, actually, testing is conducted with the code. Like whatever the code is written for the application, so it is checking one by one, line by line. But in black box, we are checking on the UI, like a complete application we are testing without
Okay.
knowing the code. Without knowing the code. So another one is gray box testing. It is a software testing technique to test a software product or application with partial knowledge of internal structure of the application. The purpose of gray box testing is to search and identify the defects due to improper code structure or improper use of application. So gray box is a mixture of a white box and black box. So if we are going with the gray box, so in that we are testing the code as well as we are testing the application from UI part. So the gray box testing is a software testing method, which is a combination of both white box and a black box method. In white box, we are testing internal structure, like whatever code is written is testing, and in black box testing, internal structure code is unknown for us. Like in gray box testing, internal structure is partially known, like like half of the code we know, like whatever the code is written, so I can test, and apart from code, we can test the application on UI part. So it's a mixture of black box and white box. So any question in the methods of testing?
Are we gonna go over white box testing and gray box testing or no?
If we know the code, like if we know the language, if we know the application language, if we know the code, then we can go the white box. But maximum time we are not doing a testing on white box. We are just testing on black box. Okay, because white box is like the code, like whatever the written in the backend. So the developer is test and check whatever the code is written. It is proper. It is it can be reusable. It can be exceptional or exceptional there. So these are things developers are checking, but
Oh, okay. So
mainly we
actually the
yeah.
go ahead, I'm sorry.
No,
You
no, no,
finish your
no worries.
oh so actually the QA is in charge only with the black box testing, right?
And for gray box, like if we know the some part of code, so that we can go with the gray box.
So just to understand this, so first state, so the state would be the circle. So the first state is the you made a reservation, right? It's the
Yes.
okay. So we go from there. What about this give info? Is this like the first arrow would be a transition? Oh, this one like give info start pay timer.
It's basically before the reservation, like if uh, before the reservation, like if you are trying to reserve anything, so you have to go to the particular website or particular site or app.
Oh, sure. Oh, okay. Okay. So first state would be made a reservation. Okay. Once the reservation is paid, so that would be an event. So pay money would be an event, right? The state is changing in a paid state.
Yes.
One of the requirements there, it was the pay money can be cash, credit cards, whatever. What do we do with that information? Nothing for now, or
Pay money in a paid, we can consider all the payment methods. Either it's a cash, credit card, debit card, wire
oh,
transfer, and all.
okay, okay, good. So then once it's paid, um, the ticket is printed,
Yes.
and that causes the state to change in a ticketed state.
Mm-hmm.
And then not if once you give the ticket to the whatever that person, then the state is changing in used ticket.
Yeah, whatever the ticket, when the ticket is generated, after that it can be used by the user. Once his
Yes.
boarding, once the boarding the plane or train. So that means user has used the ticket.
Okay, good. Yes. Boarding is what I meant, boarding. Good. Then the requirements, the reservation before it's paid, it can be canceled by a customer. No.
Yeah.
Okay.
So yeah, go ahead.
The reservation can be canceled for non-paying. Okay. And this would be a different state, right?
Yes.
Then from here, another one would be reservation canceled by the system. I did this. What did I put here?
See,
I think
there are
hold on.
three things. One is if the reservation cancelled by the customer. Okay. Second one is if the time is expired, or like
Yes.
so if the time expired, or another one is if the company has cancelled the reservation.
Okay. Yes. Reservation canceled by the system. So that is if the time expires.
Yes.
Okay. Yeah. Okay. And then what else? And then I had another arrow because it said even before or after it's paid. So I did another state canceled by customer. It goes from the paid state too. Yes. Okay.
Yeah, once in this state, once you pay the payment, after that, if you want to cancel that reservation, and that after cancel, if you want to refund, so that it will consider as a cancel or refund
Okay.
after
Okay.
payment. Actions either cancel, refund, either print ticket, either cancel, return, either give info, start pay time. These are all the actions. Basically, tag is nothing. We can consider as a test case, or like what we can consider as a test case. So we have to focus on we have to like understand the valid partitions, valid boundaries, and null boundaries. That's the thing. So for a time being, you can pick any application on Google, and you can start like doing some basic testing, like for your understanding, like what are things you need to consider, and what are the test cases you need to return. And also you can write the test cases like this, a decision table, like if a user is married. So first one is unmarried, second test case is married, another one is divorced, another one is prefer not to disclose. These are test cases you can write.
Okay. And you said if I want to just practice more,
Yes,
just
you can pick any application and just start the practice, so that you can understand what are things we need to consider to test the application. Any application you can pick, or if you can start with the login or basic application, so it will be good for you.
All right, let's test your knowledge. Here's a question for you. Which technique involves testing without looking at the internal code structure? Option A, white box testing. Option B, black box testing. Option C, gray box testing. Option D, unit testing. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
So, Module 5 is all about functional testing techniques, or we can say that the dynamic testing. So, in this testing, we have some types like GUI testing, bound BVA, ECP, error guessing, backend testing, database, compatibility, security, portability, configuration, and recovery testing. So we'll start from GUI testing. So first of all, GUI is it's kind of a graphical user interface which user has interact the application. So GUI testing is a process of ensuring proper functionality of the graphical user interface for a given application and making sure it conforms to its written specifications. So, whatever the specifications are written, it should be there and should be a proper UI so that user can see or user can use the application. In addition to functionality, GUI testing evaluate designs, elements such as layout, colors, font size, labels, text boxes, formatting, captions, buttons, lists, icons, links, content, CSS, and all. So these are things we are considering in the GUI. So why we need for GUI testing? So first one is a normal user first observe the design and looks of the application, a software, and how easy it is for him to understand the UI. Like if I'm a user, if I'll visit any application, if the UI is good, then definitely I'll go in again and again. But if I'm confused, not able to use the application, that I'll not go again. So second point is same, like if user is not comfortable with the interface or find application complex to understand, he would never going to use that application again. That's why a GUI is a matter for concern, and proper testing should be carried out in order to make sure that GUI is free of bugs.
So in other words, this one is more like how user-friendly is the application, right? Like how easy is for the user to use it. Okay.
Correct. So what we need to check in GUI testing, we need to check all the GUI elements for size, positions, width, length, and acceptance of characters or numbers. We need to check if you can execute the intended functionality of the application using the GUI. Check error messages are displayed correctly. Whatever the validation is there, it should be correct. Check for clear demarcation of different sections on the screen. Check font used in an application is readable. Check the alignment of the text is proper. Check the color of the font and the warning messages is pleasing. Check that the images have good clarity. We need to check that images are properly aligned. We need to check the positioning of elements for different screen resolution, like sponsor. So these are things we need to consider, we need to check while doing the GUI testing. So GUI testing techniques are under this approach, graphical screens are checked manually by testers in conformance with the requirements stated in the business requirements document. So in the techniques, we are checking manually the requirements which is mentioned in the SRS. So another one is record and replay. So GUI testing can be done using automation tool. This is done in two parts. During a record, test steps are captured by the automation tool. and during playback, the recorded test steps are executed on the application under test. So QTP is one of the example for GUI testing. So another one is model-based testing. QTP is a automation tool which we are
Oh, okay.
using for GUI testing. The model-based testing is first the input will be a first number is 16, second number is 64. The expected result is it should be 80. If we plus 16 and 64, it should be 18. The model based, so whatever the input we are giving, the expected should be correct. And if the expected is not coming, in that case, the validation or the warning message should be displayed correctly. A model is a graphical description of a system behavior. It helps us to understand and predict the system behavior. It helps in the generation of efficient test cases using the system requirements. And the following needs to be considered for this model-based testing. So, in the model-based testing, first of all, we are creating or we have built the model, determine the inputs for the model, like whatever inputs we are going to enter. Then calculate the expected output for the model. If we have a 64 plus 16, so the 80 is the expected answer, expected behavior, and then run the test, compare the actual output with the expected output. So the actual output is like whatever we have received once we submit, and the expected is we have already mentioned like if we go with 64 plus 16, so it should be the expected result is the 80. So it's we are just comparing the actual and the expected output. And the other one is a decision on further action on the model. So another one is boundary testing. So it is a process of testing between the extreme end or boundaries between the partitions of the input values. So these extreme ends like start to end, lower to upper, maximum to minimum, and inside to outside.
So this one is another testing technique. So we're done with the
Yes,
GUI, right? Okay. Okay.
yes. If you remember, yeah, we are considering in for GUI. So these are the components which we are using to doing the BVA. We have already discussed earlier also about the boundary value.
Oh, the
So
BVA.
yes, right.
Okay.
So in the basic idea in normal, boundary value testing is to select input variables values at their like minimum, just above the minimum, a nominal, just below the maximum, and the maximum. So BVA is another widely used case design technique for black box. It is used to test boundary values because the input values near a boundary have higher chances of error. So whenever we do the testing by boundary value analysis, the tester focus on by entering the boundary value whether the software is producing correct output or not, or whether the software is giving expected answer, expected result or not. So BV are those that contain the upper and lower limit of a variable. Like if you remember, if we enter like the expected, the nominal value is 10 to 30, 10 to 20. So we'll test with minus to 0 or minus to 10. Then 10 to 20 is the nominal, and then 20 to 30, 40, 50, 60 and all. So another one is ECP. So ECP is a black box test design technique. In equivalence partitioning, we divide the entire possible input range into partitions. So if you remember the ECP, we have tested like a minimum like less than 0 to 16H, then 16 to 18, then 18 to 34, and then 34 to 60. So after partitioning, we may pick any value from the partition and test accordingly. The assumption is that if we pick a value from an invalid partition, the system should reject that value, and if it doesn't, then the system fails the test. So if the value, if we are giving the invalid value, so in that case, the validation message should be there. But if the validation message is not coming, that case that test case is fail or the application is fail while testing. Likewise, if the value is from a valid partition, the system should accept the value. We pick exactly one value from each partition. So for ECP, these are the range for a particular system, like age 21 to 70 years, except for 30 to 35. Okay, so in this, invalid partition is less than 21, valid is 21 to 29, invalid is 30 to 35, then valid is 36 to 70, and then valid is 70 plus. These are the partitions we have because we have expected values. We have age 21 to 70, it should be there. So another one is error guessing. So it is a technique based on guessing the errors that prevail in the code. It should be used as a mopping up technique or as a supplement to systematic techniques, but not as the first choice approach. It can help to find numerous faults that systematic techniques may fail to detect. And the last one is this method mostly depend on the tester's previous experience and as to where defects can take place in the future. So, what are the factors to consider in error guessing? First one is application risk reports, previous project experience, identify defects, production tickets, checklist, and test execution report. So, there are some exist common mistakes that should be tested primarily. So, if we are actually we are considering a calculator application. So, first of all, a division by zero. Second, entering blank space into text field. Then entering invalid values and submitting without value specification, and then uploading files that exceed the set limits. Another one is negative testing. So it is a software testing type used to check the software application for unexpected input data and conditions. Unexpected data or conditions can be anything from wrong data type to strong hacking attack. The purpose of negative testing is to prevent the software application from crashing due to negative inputs and improve the quality and stability. So what are the negatives? Like if we giving the unexpected, if we enter an unexpected values or spatial characters, something like this, so we are considering as a negative testing because some special characters like @ hash are not supporting the applications because these characters which we are using in our code in the backend code. That's why. So the difference between negative and positive. So what happens if the number of persons exceed the specific limit? What happens if someone smoke or cause a fire inside the lift? What happens if there is a power failure during operation? So positive testings are assumes the only specified number of person will enter the lift. And the second one is there won't be smoke or fire inside the lift. And the another one is won't be a power failure during the working of the lift. So now we'll discuss about the backend testing. So it is a testing method that check the server side or database of web application of a software. The purpose of backend testing is to test the application layer or database layer to ensure that the web application or software is free from database defects like deadlock, data corruption, or data loss. Backend testing is also known as DB testing. The data entered in the front end will be stored in the backend. The database may be SQL Server, MySQL, Oracle, DB2, etc. So in backend testing, we are checking whatever data we have entered on the UI, it should be same in the database. And once we refresh the page, so the same data should be displayed in the fields. First of all, here is a presentation layer, which is like front-end testing. Then the business layer, and database layer. So these are the two things which we consider in the backend testing. And the presentation layer or user interface we are considering for front-end testing. So, types of database testing. First of all, structural testing. Second is non-functional, and the next one is functional testing. So, what are the advantages for backend testing? So, backend testing is not like a black box. It's full control of test coverage and depth. In early development stage, many bugs can be effectively found. So, are you clear on the backend testing? See, backend testing is like a database. Whatever every application required a database, and every application requires a database testing as well. If there is no database, then without database we cannot run or we cannot use the application. So a database is a pre-arranged collection of data containing the information and helps in data manipulation. A database can easily manage and retrieved by the user. We can establish data into tables, rows, columns, indexes, making it easier to identify the appropriate data. In a database, data management becomes a very easy task because we can use a database as it is to retrieve the information like tables for storing data, functions, triggers for data manipulation, and view for data representations. So what is the purpose of database testing? So first of all, are transactions, asset properties, data mapping, accuracy of business rule, and data integrity. So next one is compatibility testing. So it is nothing but the capability of the existing or living together. So in normal life, oil is not compatible with water, but milk can be easily combined with the water. So types of compatibility testing are hardware, operating systems, software, network, browser, devices, mobile, and versions. Now, we have two types of version checking in compatibility. First one is backward and second one is forward. So another topic is security testing. So it is a type of software that uncovers vulnerabilities, threat, risk in a software application, and prevent malicious attacks from the intruders. The purpose of security tests is to identify all the possible loopholes and weaknesses of the software system, which might result in a loss of information, revenue, repute at the hands of the employees or outsiders of the organization. So security testing we are doing just because our applications should be safe. No hackers can enter or break our application. So why security testing is important? The main goal of security testing is to identify the threats in the system and measures its potential. So the threats can be encountered and the system does not stop functioning or can be exploited. It also helps in detecting all possible security risks in the system and helps developers to fix the problems through coding. Another one is portability testing. So, a portability testing is a process of testing which ease with which the software or product can be moved from one environment to another. So, it is measured in terms of maximum amount of effort required to transfer from one system to another system. The portability testing is performed regularly throughout the software SDLC in an iterative and incremental manner. So there are some attributes of the portability testing. First one is adaptability, installability, replaceability, and coexistence. So these are checklists of portability testing. So verify if the application is able to fulfill the portability requirements. Determine the look and feel of the application in the various browser types. So we are checking the UI elements in all the browsers so that in every browser the application element should be same or the functionality should be same.
So we're checking if the same software would go well on a different, like would, I'm sorry, would work the same, for example, on the laptop or tablet or something like that, or no?
We can consider the different browsers or different devices. Like if you're talking about the laptop, tablets, mobile, so the application should be responsive. Responsive in the sense it can be adjusted as per the resolution of the device. So these things we need to consider. We also need to consider in portability and also a different browsers. Like if we are using Chrome, if we are using Edge, if we are
Oh,
using
yes.
Safari. So next one is the failures during the portability testing can help to identify defects that were not detected during the unit and integration testing. So another one is configuration testing. So it is a type of software testing which verifies the performance of the system under development against various combinations of software and hardware to find out the best configuration under which the system can work without any flaws or issues while matching its functional requirements. It is a process of testing the system under each configuration of the supported software and hardware. These are examples of the configurations. Like if our application is supporting the only Windows 10, so it should be mentioned in the Windows 10, and also we need to check in the with the Windows 10. And the database configurations are like whatever database we are using for the application, and the browser configuration is which version of a particular browser we are using. So, what are the objectives of configuration testing? To determine whether the software application fulfill the configurability requirements, to identify defects that were not efficiently found during different testing process, to determine an optimal configuration of the application under test, to do analyze of the performance of the application by changing the hardware and software resource. Like if we change the hard disk or if we change the Windows like this, so or software, so we need to check, we need to consider this to do analyze of the system efficiency based on the prioritization to verify the degree of ease to how the bugs are reproducible irrespective of the configuration changes. So now under another one is recovery testing. So it is software testing technique which verify the software ability to recover from failures like software hardware crash, network failures. So in this, we have to prepare if any of the software or hardware is crashed during the process, during the application testing, or during the application users. So how we can recover that things. The purpose of recovery testing is to determine whether the software operations can be continued after disaster or integrity loss. The recovery testing involves reverting back software to the point where the integrity was known and reprocessing directions to the failure points. So in this point, we are checking if I'm able to log in the application and in any case the application is crashed due to any software issue or network issue or hardware issue. So once again, if I back to to the application, so the last point it should be displayed correctly. So the life cycle of recovery process: a normal operation, disaster occurrence, disruption and failure of operation, recovery process, and reconstruction normal process. So these are techniques which we are using in testing.
When we try on obviously a software for errors or bugs, are we using all these testing techniques, or we have to pick and choose which
No,
one
no,
is the best for? Go ahead, sorry.
no, we have to consider all the things because GUI is a separate thing, black box is a separate thing, recovery is a separate, security is a separate. So all the testing techniques having their own criteria, their own results. Like
Yes.
like if a login, like you are going to test a login page. So in this, you have to consider GUI as GUI testing, functional testing, uh, cross-browser testing, like login page should be same in all the browsers, and the compatibility testing, like the application is met the requirements of the software or hardware. Recovery testing, like if the network fails while using the application, so in that how application should recover. So all the things we have to consider while doing the testing.
Okay, so we're using all the techniques.
Yes. Next, I think we have like 5 modules already discussed. So it's I think we should you can go through all the modules and then we'll go through further modules, right? No, no, I'm saying we have discussed 4 or 5 models in the last sessions
Oh yeah,
or
yeah.
today's sessions, yeah. So instead of going first, so you have to go through the all the modules and understand all the things so that the basic criteria, the basic things, it should be clear to you.
Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
So today I'll discuss about the performance testing, which we are doing after the functionality testing is completed. Once the functionality testing is completed, then we'll start the performance testing. Just like to check if multiple user hit the application, or if like 1 lakh, 2 lakh, 10 lakh users hit the application at the same time. So at the same time, what is the like expected behavior of the application? Like it should be crash, it should be handle, something like this. So it is a non-functional software testing technique that determines how the stability, speed, scalability, and responsiveness of an application hold up under a given workload. And it's a key step in ensuring software quality, but unfortunately is often seen as an afterthought in isolation and to begin once a functional testing is completed. And in most cases, after a code is ready to release. So once we have completed the testing for like all the things, all the functionalities working fine as per the requirement, then we'll start the performance testing. So what are the reasons for performance testing? First, to determine whether the application satisfies the performance requirement. For instance, system should handle up to 1,000 concurrent users. Like this is an example. So we can then check with 1 lakh, 2 lakh, 10 lakh users at the same time if they are hit the application. To locate computing bottleneck within an application, to establish whether performance level claimed by a software vendor are indeed true. Like if any company is claimed that the application can able to handle 10 lakh user at a time, so that we are checking if the 10 lakh users hit the application at the same time, so it will handle or it will like crash or it will something like this. To compare two or more systems and identify the one that performs best to measure stability under peak traffic events. So what are types of performance testing? First, identify the performance scenarios. Second, plan and design the performance script. Next one is configure the test environment and distribute the load. Next one is execute the test scripts, then result, then analysis, then identify the bottlenecks. Bottlenecks means issues, or if we found any issues, so in that case, we are just identify the scenarios and then rerun the test. Next one is load testing. So it is a non-functional software testing process in which the performance of software application is tested under specific expected load. It determines how the software application behave while being accessed by multiple users simultaneously. So the goal of load testing is to improve performance, bottlenecks, and to ensure the stability and smoothness of the functionality of software application before the deployment. So these two are clear for you, performance and load.
I think so. So in other words, we want to test if for example, an application it can be handled by 100 people at the same time. It can be used by 100, for example, 100 people at the same time. Is that correct?
Yes, for example, like a Black Friday sale. So
Okay.
if Amazon are claimed that they can handle 1 lakh users at the time, so that we can check on the same like if 1 lakh users hit the same time of the application, so it is handled or it's crashing too, because if you know, if you see sometimes the sites are crashing on the sale day.
Yes, yes.
Or sometimes it is running very slow because of the users, because of the traffic.
Yeah,
So
there's too much traffic. Yeah.
yeah, that's why we are doing a performance and load testing.
So load testing would be one of the performance testing techniques, right?
Yes, it's a type of non-functional testings. Basically, these are testing we are considering for in a non-functional testing, because we are not testing any functionality in this. We are just checking the load or checking the traffic. So next one is GUI testing, which is called as a graphical user interface. So this testing usually identifies the maximum operating capacity of an application, determine whether the current infrastructure is sufficient to run the application. Another one is sustainability of application with respect to peak user load And next one is a number of concurrent users that an application can support and scalability to allow more users to access it. So, what are the goals of load testing? So, first is response time for each transactions, performance of system components under various load, performance of database components under different load, network delay between the client and the server, software design issues, server configuration issues like a web server, application server, database server, and the last one is hardware limitation issues in like CPU maximization, memory limitation, network bottleneck, etc. So these are the goals we are considering while doing the load testing. So an environment needs to be set up before starting a load testing. So for hardware platform, it's server machines, processors, memories, disk storage, load machine configuration, and network configuration. And in the software configuration, there are two things, operating system and server software. So next one is stress testing. It is a type of testing that verify the stability and reliability of software application, like the applications how much reliable for any user. The goal of stress testing is measuring software on its robustness, like how good it is, how the users can use a application easily or not. They can understand the terms, they can understand the UI easily or not. So, and error handling capabilities under extremely heavy load conditions. So, if the traffic is more, in that case, we are checking there should be an try catch or the exception, the error should be handled. Like if there are more users and if they hit the application should not be crashed. If it's crashed, so it should not show to user. It can be handled by the try catch model or in the exception. Same ensuring that software doesn't crash under current situations. It even tests beyond normal operating points and evaluate how software works under extreme conditions. So, load testing versus stress testing. So, load testing is to test the system behavior under normal workload conditions, and it is just testing or simulating with the actual workload. Load testing doesn't break the system, and we are going the stress testing. So, it is to test the system behavior under extreme conditions and is carried out till the system failure. It tries to break the system by testing with overwhelming data or resources. What are tools recommended for stress testing? Load runner, stress tester, JMeter, and NeoLoad. So, load runner from HP is a widely used load testing tool. Its results are shared by load runner are considered as a benchmark. JMeter is an open source testing tool, so you can find JMeter easily on Google and you can use it. But a load runner, it is not an open source. We have to buy we have to purchase the license if we need to use.
As a practice for this training or in general when we do
In
it in a
both,
job?
in both, in both,
Okay.
in practice or in general, load runner is not an open face source application. So anyhow, if you want to use, you need to purchase a license. But for JMeter, it is free. You can find it. You can find easily on Google, and you can start working on it. And it is a pure Java application for stress and performance. And it is intended to cover types of tests like load, functional, stress, etc. It needs JDK version or higher to function.
What does it mean, JDK? This what JDK5? What is it?
That is a library, Java library. So in some applications, in some Java-based applications, we have to set up the environment, and we need to use the JDK versions. JDK is one of the library from of the Java language.
Okay.
So what are the tools? And another one is stress tester. So these tool provides extensive analysis of the web application performance, provide the result in graphical format, and it is extremely easy to use. No high-level scripting is required and gives a good return on investment. And the next one is NewLoad. It's a popular tool available in the market to test the web and mobile application. This tool can simulate thousands of users in order to evaluate the application performance under load and analysis the response time. It also supports cloud integrated performance, load and stress testing. It is easy to use, cost effective, and provides good scalability. So, what are the metrics for stress testing? So, first one is measuring scalability and performance. So, in this, pages per second measures how many pages have been requested per second. Like, first we need to check the page, how much time it's taking to load. Second
Oh,
one is
okay.
to, yeah, because sometimes the page took like more than 1 minute, 2 minute, and sometimes it is loading in a 2 or 3 seconds. So in this, we are checking how many requests we are sending to the server, and how much time it is taking to load the pages. Next one is throughput. Our basic metric response data size per second, and another one is round. Number of times test scenarios have been planned versus number of times a client has executed. So whatever of scenarios we have planned, and how many scenarios client has executed. So next metrics is application response, like hit time, average time to retrieve an image or a page. So we are just checking an average time if we load the application or if we load the images. So how much time it's taking. And another one is time to the first byte. Time is taken to return the first byte of data or information. And another one is space time. Like time is taken to retrieve all the information in a page. Sometimes page load, but with the partial information, and we are checking this once a complete page is load. So in that it is retrieving all the application all the data or partial data. Another metric is failures of failed connections. Number of failed connections refused by the client for weak signal. Number of rounds it gets failed, and number of failed attempts done by the system, like broken links or unsent images. So, do you have any doubt, any query for stress testing? So, what is scalability testing? So, it is a non-functional testing method that measures performance of a system or network when the number of user requests are scaled up or down. The purpose of this testing is to ensure that a system can handle projected increase in user traffic, data volume, transaction counts, frequency, etc. So why do we need to do a security testing? So it lets you determine how your application scales with increasing workload. It determines the user limit for the web application. It determines the client-side degradation and end user experience under load. And it determines the server-side robustness and degradation.
Do you have like a example for scalability testing? I mean, like something that I don't know when we're using this one, like for what?
Right now, I don't have any example, but I can note it down. Yes, I have written down the points, so I'll come up with an examples. Like if I found the practical things, I'll tell it is good. So I'll check if we have any site or any web application so that we can check the scalability testing. Another one is soak testing. So in this, first a load distribution capability. So check whether the load test tool enables the load to be generated from multiple machines and controlled from a central point. Another one is operating system. Like check what operating systems do the load generation agents and load test master run under the soak testing. Another one is a processor. Check the what type of CPU is required for a virtual user agent and load the test master. And the memory, check how much memory would be enough for a virtual user agent and load test master. So in this, we are checking for the application like which is the minimum requirement, OS requirement or maximum requirement, which is how much memory, how much RAM we need to use the application. Like if you can see in some site or in some applications, there are mentioned like the software requirements and the hardware requirements. Like what are softwares you need to you need to be there in your system, and what are the hardware configuration like 1 GB RAM, 2 GB RAM, or minimum Windows 7, Windows 10, or minimum Intel i3 processor or i5 processor. So these are things we are considering in the soak testing. So it is a type of non-functional testing that is used to measure performance of a software application under a huge volume of load for an extended period of a time. The goal of soak testing is to ensure whether the software application sustains high volume of usage and to check what would happen outside its design expectation. So another one is like what are the characteristics of soak testing? The duration of most soak tests is often determined by the time available. Any application must run without any interruption. If it requires an extended period of time, it should cover all the scenarios that are agreed upon by the stakeholders. And mostly every system has a regular maintenance window time period, and the time between such window period is a key driver for determining the scope of a soak test. So maintenance window time is like in a month, in a 20 days, or in a 2 month. We need to check the performance, and that time we just need to put the message like the maintenance is going on, and it will be live on after half an hour, after 1 hour, or it will be the application will not be available from this time to this time. So uh, that is a maintenance window time. If sometimes you got a message from the bank that application or web application, it will not be available from 12 a.m. to 1 p.m. 1 a.m. because of some kind of maintenance. So next one is volume testing. What is volume testing? Basically, it is a type of software testing where the software is subjected to a huge volume of data. It is also referred to as flood testing. It is done to analyze the system performance by increasing the volume of data in the database. With the help of volume testing, the impact of response time and the system behavior can be studied when exposed to a high volume of data. So in this, if we have an application and if we put if multiple users entered the multiple data, like for example, on Amazon side. Um, at a time, like 1 lakh users has logged in, and they can enter the data in this in the Amazon, like to search or to add the cart or to billing or anything kind of this. So it's a huge testing, huge volume. So basically, we are checking with the maximum data of the first testing. Like if there is any field and if multiple users enter the data on that field, so we are checking the expected behavior. Like it can be handled huge data. It is hanged. Sometimes some applications are hanged just because of more data. So that is the thing we are checking in the volume testing. So what are the benefits of volume testing? By identifying the load issues, a lot of money can be saved, which otherwise will be spent on application maintenance. It helps in a quicker start for scalability plans, early identification of bottlenecks, and it assures the system is now capable of real-world usage. Why we need to do a volume testing? Basically, we are checking the system performance with increasing volume of data in the database. Like in maximum applications, they are mentioned that 1 GB of RAM required or 2 GB of RAM required. So if we are using the multiple applications in a system, and if the CPU usage is going more than 80% or 90% or 95%, so in that case, our our system is hanged. So that is the thing we are considering in this, like if system is hanged or not, how much data is system can be handled or application can be handled. To identify the problem that are likely to occur with the large amount of data, to figure out the point at which the stability of the system degrade, and the volume testing will help to identify the capacity of the system or applications, normal and heavy volume. So how to do volume testing? Like test to check if there is any data loss, check the system response time, check if the data is stored correctly or not. Like whatever data you have entered in the application, so once you submit, the same data is showing in the application or not. Verify if the data is overwritten without any notification. Like if you have entered something like test data, and once it's after submit, you can just you can able to see the data, but a different sentence like a data test. So that is we need to check, like without notification, it should not be overwritten. Check for warning and error messages, whether it comes all for volume problems. Check whether the high volume data affect the speed of processing. Does system have the necessary memory resources? And this volume test executed on the whole system. Is there any risk if data volume is greater than specified? Is there any guarantee that no larger data volume will occur than specified? So these are the things we are considering while doing the volume testing. So this is all for non-functional testing, or we can see this testing as a non-functional.
I was gonna ask you about, okay, so when we start testing something, we go first through the functional testing techniques, right? Yeah. So we'll start with the functional ones, and then after we're done with that, we go and start testing for non-functional performance.
Yeah, yes. In a non-functional, basically we are considering in the last, or parallelly we can do if we have a team, so a separate team for functional and non-functional testing, so we can parallelly say. But if we don't
Oh,
have, yeah, if we don't have team, for both yeah.
If you don't have, I mean, if the company doesn't have teams, you as a QA, you have to go through all this testing techniques, right? Functional and
Yeah.
non-functional.
Yeah. By the way, in today's era, or maximum companies having different teams for functional and non-functional testing. So in that scenario, because of like time consuming, so that's why they are doing they're performing parallelly. Like one team is working on functional and one team is working on non-functional. But in some companies, they don't have this separate teams, so they are working first with the functional, and then last once the functional testing is completed, then they can pick the non-functional testing. Okay, so these are the testing which is considered as a non-functional testing. For non-functional testing, you can search some tools like these tools, and you can just go through the tools and how we can use these tools. So you just have a understanding of the tools. Yeah, load runner is a paid,
I
but
have to
you
buy
can,
it. Yeah.
yeah, but you don't need to buy. You can check with the stress tester, JMeter, Neoload. These are the free open source tools.
Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
We'll discuss about the like how we can identify the scenarios, or we can say that the test cases. Okay, so first topic is what is use case. So a use case is a written description of how users will perform tasks on your website. So basically, use case is like to identify the functional and business requirements of the application,
Okay.
and it outlines from a user point of view a system behavior, and it responds to a request, and each use case is represented as a sequence of simple steps beginning with the user's goal and ending when the goal is fulfilled. So how we can design a test cases? So test case design refers to how you set up your test cases. It is important that your tests are designed well, or you could fail to identify the bugs and defects in your software during testing. So every time, for every release, write write the for new requirement. We can write the test cases, and for every release, we can run the test cases which we have for just a smoke integration. So do you know the difference between smoke and integration? Okay. So smoke testing is
You said
when we are
small, like small.
no, it's no smoke. SMOKE, smoke.
Oh, smoke, like smoke,
Yeah.
cigarettes, for example, smoke.
Yes, yes, yes.
Okay.
So smoke testing is like what? We can just check the basic functionality of the application, and regression is like we can check the basic functionality as well as new implementation and integration testing.
This case, it's used in the functional, right? In the functionals testing.
Basically, yeah, test case is like we are writing a test case to check the application. Like if we have a login page and there are two fields, username and password. So the test case is test scenario is verify the username and password, and the test case is will check the positive cases as well as negative cases. So every like test scenario is having multiple test cases. So last point is designing good test cases. Ensure that every aspect of the software get tested so that you can find and fix an issue. So if we don't return the test cases, so every time we need to recall things like if you have a release or if you're testing the application and you have found multiple many bugs. So in the next release, if you don't write a test case, you have to recall that bugs so that you can test the functionality. That's why we are writing a test case so that we don't need to recall. We have a test case. We can just go through the test case and doing the testing.
So test cases, in other words, would be whatever mistakes or bugs we find, errors we find, we just create a test case for that so we know what the bug is, right? So we can always go back to that information. Am I?
Yes, yes,
Okay.
yes. For bugs as well as a functionality. And for this, we don't need to recall every time because if today I have tested a new functionality and after 4 5 months, if I need to test the same functionality in that case, I have to recall if we don't have a test case. But if we have a test case, we can just go through the steps and we can do a smoke testing on it, do a like basic testing, or we need to check the all the functionality whatever we have implemented earlier. So a basic example of a test case design is first is title, like either it's a page name, either it's a module name, either it's a app name.
So, for
Uh,
example, the title would be Facebook. Is it? No.
yes, we can, but if Facebook login having multiple functionality in that, we can choose a login instead of using Facebook. We can just write a Facebook login that or verify the login page like this. Because if you have multiple functionality in that, also you can confuse like what is a functionality it is. It's related to login, it's related to register, it's related to forgot password or something like this. The second one is description. So a user should be able to successfully log in into their account on the website and app. Another one is preconditions. So a user must already be registered and use their correct login details. Assumptions are they are using a supported device or browser to log in. So these are the titles we can use for to write the test case. And test steps are open website or app.
The assumptions, they are using a supported device or browser to log in. Oh, you mean browser would be using Chrome to log in?
It can be assumptions can be a expected behavior. Like what should be like if I log in. So in that case, if we are using Chrome browser, we are using Edge browser, we are using mobile app. So the assumptions are like it should be supported in the for the app. And another one is test steps. Like steps are like the steps. It's like if you can just open the website, you can just open the you can open the website or app You can enter the username and password and click on submit. And the expected result is user should be logged in successfully. If we show the example, so title I have written verify the login page. So description is user should be able to log in successfully into their account. Preconditions like before the like conditions which we have before the login. So user must be registered in the app. So if user is not registered, in that scenario, you can that your test case is failed. This one is will be failed if user is not registered on the application. Assumptions are using browser version, or release, or hardware or software should be supported. Now the test steps are open the specific browser, open the Facebook app, enter the valid username password, click to log in. After login, the actual result is able to log in successfully, and the expected user should be able to log in successfully. So actual and expected are same, but if user is not registered on the app, so if the user is not registered and if we follow the same test steps, so that this test case will be failed because a user is not registered on the app. So once you run the test step, you can found that the actual result is user is not able to log in, but the expected result is it should be log in. So it is failing because it is not user is not registered. So like this, we are writing the test cases for valid, invalid, positive, negative test scenarios.
And if the test case fails, do we create another test case? No. Yes.
No, we don't need to create another one. We can just mark as failed, and once it's fixed, then we can rerun the failed test cases. So we have different type of test cases. First one is functionality test cases. Functionality test cases are used to discover if an application interface works with the rest of the system and its users. The test identifies the success or failure of functions that the software is expected to perform. The cases are a type of black box testing that uses for its base the specification or user story of the software under test. This allows the test to be performed without needing access to the working or internal structure of the software being tested. The QA team are usually the writers of functionality test case because the task falls within normal QA process. So basically, it's a functionality. In this slide, we can write the functionality test cases, only positive test cases. So we have like UI test cases. We have user interface test cases. So in this, it is used to verify that a specific piece of GUI look and work as expected. So if we have label of login and all are regular, like a login word is regular and password word is regular, so we can we can write in the test case that the login and password labels are should be a regular test case, not a small, not a capital. And another one is these type of test cases can be used to identify cosmetic inconsistencies, grammar, spelling errors, links, and any other elements the user interact with or see. These cases are usually written by a testing team, but the design team may also be involved as they are most familiar with the interface. UI test cases are a type of test cases in software testing that usually drive cross-browser testing, and it tend to render things differently. And UI test test case help ensure your application behave consistently across multiple browsers. So in the UI test cases, we are checking all the elements which we on the page and all the spelling, all the margins, all the paddings, all the things like it related to GUI, we are checking in this UI test cases.
So again, this test cases, it's not a technique, right? It's not a technique to check if the to check the functionality of a application, for example, right? It's not.
Basically, use test cases is a different kind of test cases. And if we can say test cases written for to test the functionality, test cases written for check the UI elements. So all the things, if we are going to test for the application, so all the things are considered in test cases. Either it's a functionality or either it's a content or either it's a GUI, either it's a validation message, either it's an like spelling mistakes. All the things will be in test case. So if we are going to write the test case, we need to consider all the things, functionality as well as UI, as well as uh, spelling mistakes, as well as labels, all the things we need to consider.
So this step, again, maybe whatever. So this step, this test cases, we do it once we go through all the functionality techniques, right?
Yes. Once you gone through the techniques, then you can start to write the test case.
Okay, so practically test case, it's everything what we find, you know, if we find a mistake or anything, we just write it down. It's our, I don't want to say journal, but you know, it's that idea that everything we see, we find, the mistakes, bugs, we have to write it down in test cases.
So this is my page. So if I need to write the test case, so first of all, first title is verify login. So we have written the login functionality. It's a test case. Like it's the one test case I can mention there. Test case one. So another test case is test case two. So verify the labels of login page. Assumptions are optional. You can write or you cannot. So the test step is open the specific browser, open the Facebook app. Another test case is verify the labels of the login page. So test step is open the specific browser, open the Facebook app, verify the login field placeholder. So the placeholder is email or phone number, and another one is verify the password field placeholder. So for password, it should be a password, and verify the login label. Login label should be a log space n, and the actual result is all the placeholders are in place already, and expected is all the label should be there as it's expected.
Okay.
So, got my point?
Yeah, I think I understand now.
So
thank you.
Everything I need to write, every functionality, yes, everything we need to write. Like if we are going this test to check this page, so everything we need to consider, like UI test case, functionality test case for login, what is the functionality on forgot password, what is the functionality if I change the language,
the color, the font, everything, right?
yes, all the things we'll consider in the test case.
Oh, so I mean, for a page, you can end up having a lot of test cases, right?
Yes, you can write many test cases for this. Like more than one, two, like more than 10, 12 cases you can write for this page. Another one is performance test cases. So it can validate response time and overall effectiveness of an application. That is, after executing an action, how long does it take for the system to respond? Performance test cases should have a very clear set of success criteria. The testing team typically writes this test case and they are often automated. A large application can have hundreds or thousands of performance tests, and the automating these tests are running them frequently help expose scenarios where the application is not performing at the expected level. So another one is first one is functional, second one is GUI, third one is performance. So if I load the page, how much time it is taking? So for me, it's taking 7 to 8 seconds. So all the page is loaded and all with all the contents. It's taking for me it's 7 to 8 seconds. All right. Okay. So we can check the performance of the page, like how much time it's taking. Every page we can check in this.
So this is what we check in the performance.
It is checking, but basically we are using app like third-party software. But if we are not, if we don't have a third-party app like a JMeter and all, so we can check like this in the inspect. We can check the performance of the application, performance of the page, like how much time it's taking to load, and if any CSS, any API is failing, so we can just cross check in this, like which API is failing and which API is taking time. Another one is integration test cases. Integration test cases are meant to determine how different modules interact with each other. The main purpose with integration that test cases are to ensure interface between the different modules are working properly. The testing team identify which areas should undergo integration testing, while the development team will have input on how those test cases should be written. Either of these two teams may work to write the test cases. So integration test cases are basically if we have multiple modules and it's linked with each other, that called a integration. So for example, if you log in the Facebook app and if you click on the profile page, so it's a linking of the two modules. Any kind of linking we can call as a integration testing. Another one is usability test cases. So it can be often to refer to a task or scenario rather than providing detailed step-by-step instructions to ensure the test. The tester is presented with a high-level scenario or task to complete. Usability test cases help identify how a user naturally approach and use the application. They help guide the tester through various situations and flow. No prior knowledge of the application is necessary. So usability is just like ad hoc testing. It's like a new candidate, a new QA can come up in a team and they can he or she can start to test the application and just do a ad hoc and write the test cases. For example, if you are a if you are a new candidate, if you are joined a new organization as a QA and if you have a new application, so at the time of ad hoc, at the time of checking the basic scenarios, or at the time of learning the functionality or checking the functionality, you can just write the basic flow of the application. Another one is database test cases. So a test case for database testing examine what's happening behind the scenes. The UI is clean and everything appears to be working, but where is all that data going? in order to write these test cases, you need to have a strong understanding of the entire application, the database table, and the store procedures. The testing team will often use SQL queries to develop database test cases. So database is like for every application, we need a database where we can store the data. And when we are fetching, the same data should be come up on the screen. So the main quality of test cases are first one is ID, second one is priority, third one is version, fourth one is requirement ID, then module, submodule, type, description, expected, actual result, created by, last modified by, comment, add attachment. So priority is like it's a major, it's a minor, it's a severe, like this. Version is like in which version you have tested or you are going to test. Module name is whatever module we have. Submodule is like if we have multiple submodules in a single module, so we can just mention which submodule we are testing. So these are the things we need to consider while writing the test cases. So now this we can who can review the test case designing? Like if you are a QA, so you have hierarchy like QA, then senior QA, then team lead, then manager and all. So first the author, like who are going to create a test case, it can like satisfy the correctness of test case, go through the and review the content, and in another language, go through and review the functionality of the application. So do the corrections only if they're necessary. So the author or reviewer will discuss about this, and they can send to the test lead. So test lead approve the test case, and then he can test it can create the repository for the stories, and then review the documents. And once we at the time of reviewing, we can check the mistake test cases, scenario missing, wrong flow, maximum test coverage. Scenario missing is like if I can miss any test step, so I have to rewrite the test case in that scenario. Another one is traceability matrix. It is a document that correlate any two baseline documents that require a many-to-many relationship to check the completeness of the relationship. It is used to track the requirements and to check the current project requirements are met.
Can you go back to this traceability matrix? Oh, it's a document. Who creates this document? Or I'm just a little bit.
Uh, QA can create this document because only a QA can know the functionality of the application as per the business requirements. So QA can write the test cases for this, and another people can check or can use the same test case. So RTM is a document that maps and traces the user requirement with the test cases. It captures all the requirements proposed by the client and requirement traceability in a single document delivered at the conclusion of the software development lifecycle. The main purpose of RTM is to validate all the requirements are checked by a test case, such that no functionality is unchecked during software testing. So we are creating a RTM. It's kind of matrix. So in this matrix, we are mapping all the business requirements with the test case. So one requirement having multiple test cases in this. So we are identify all the test cases along with the requirement. It should be mapped and checked. Nothing can be left for software testing. for testing of the particular application. So which parameters we need to include in RTM? First one is requirement number, whatever requirement we have in the SRS. Another one is requirement description, and another one is test case ID. Like if we have one requirement and if we are creating the multiple test cases for a particular requirement, so we have to mention all the test cases here. And also we need to mention the status as well. Like whatever test case we have, it is failed or passed or no run. And like in the second row, you can see test case 06 is failed and the 7 one is no run.
Then now I can, when I see this, I can understand better what's the RTM.
So what are the importance of test data in testing? So test data is an input feed for testing the application. To feed the test data to check that the outputs are derived correct. Test data varied for different layers and testing, valid and invalid. While defining the test data, it might be useful for other users, developers, that what the system gave for the given inputs. Test data helps the developers to find a problem during fixes. Test data may be used in a confirmatory way, typically to verify that a given set of input to a given function produce some expected result. So also we are mentioning all the data which we have used for testing the application. Like if we have a login and so the data is ABC and the password is 123. So these data I have to write in a test case, like whatever test case data we have. Another one is managing test data. So a comprehensive approach should seek to improve for TDM in each of the following areas. First one is data delivery. It is reducing the time to deliver test data to a developer or tester. Data quality, meeting requirements for high fidelity test data. Data security is minimize the security risk without compromising speed. Infrastructure cost is lowering the cost of storing and archiving test data. The following section highlight the top evaluative criteria for a TDM approach. So this is like how we are managing the test data. All the things related to your test case we have covered. Okay, so for the next once you go through this module, so you have to pick any of the page or any of the login or any of the website to write the test case, and you can just share with me. So if there's any confusion or if there's any something like, we can help you out. Once you go through the module, you can just pick any of the login application and write the test case so that
to practice. So I
yes,
understand better.
exactly.
Yeah.
Yes. So that you can understand, and if there's any doubt, we can discuss and we can come up with the solution.
Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
So today we'll discuss about the module 8, which is bug or defect or error. First of all, we'll discuss about what is a bug. we have three kind of defects. One is bug, second is defect, and third is errors. So we'll start from the bug. So the bug is the informal name of defect, which means that a software or application is not working as per the requirement. So in software testing, a software bug can also be issue, error, fault, or failure. The bug occurred when developers made any mistake or error while developing the product. So if we found a bug at a time of development, that called a bug.
So even if the developer makes a mistake, we can still call it a bug.
Yeah, if that is correct. At the time of development, if we found any issue, that we can call a bug. So what is the difference between a bug and defect? So the bug, it's an informal name specifies a defect, and the defect is the difference between the actual outcomes and the expected output. Next thing, who is raised by this bug and defect? So the test engineers submit the bug, and the testers identify a defect, and it was also solved by the developer in the development phase or stage. Next one is different types. So we have a different type of bugs as follows, like logic bugs, algorithm bugs, and resource bugs. Same, we have a different type of defects based on priority, which is like high, medium, and low. So bug we can found at the time of development, and defect we can found at the time of doing the testing once the development is complete. So what is the format of bug? So an effective bug report should contain the following: a title, bug ID, steps to reproduce a bug, actual result, severity, priority, environment, expected result, and the proofs if we have like screenshots, videos, and all. So whenever we found a bug, we can follow this attribute which is contained in the bug report.
But what does it mean, steps to reproduce a bug? Like, what do you mean reproduce a bug? So first you find it, right? And then
So
step. Go
that
ahead.
that mean yeah that means if you found a bug, so you have to mention the steps like you have like once you log in the page, you have entered the login password, and then you once you click on submit, then the error is coming like this. Because if you forward a bug to the development team, so you have to mention the steps to reproduce. Otherwise, they cannot reproduce the bug and fix because they don't know how you found a bug. So, what is bug severity? So, the bug severity or defect severity in testing is the degree of impact a bug or a defect has on the software application under a test. A higher effect of bug defect on system functionality will lead to a higher severity level. A QA engineer usually determines the severity level of a bug defect. So, if we talk about the critical severity and urgent, so that means a key feature doesn't work. And if we go with the low priority but critical severity, that means a feature that is rarely used doesn't work. Same for non-critical. If we go with the urgent priority, that means the company logo is a wrong color. And if we go with the low priority, then the captain on an image is written in the wrong font. So like if any application having like a functionality issue, which is a main functionality that we consider as a critical and the priority is urgent. So, same for non-critical. If the company logo is the wrong color, company logo, margins, pattern, something like this, so that will consider as a non-critical. But priority is urgent. Did you understand about the critical and non-critical, like or severity and priority? Did you understand the difference between the severity and priority?
So the difference between the critical and the severity and priority, you mean you're asking me if I
Yes,
understand?
yes.
Yes, I do.
Next one is types of severity. So, first one is critical. Does defect indicate the complete shutdown of the process or nothing can proceed further? And the second one is medium, sorry, major. It is a highly severe defect and collapse the system. However, certain part of the system remain functional. Next one is medium. It causes some undesirable behavior, but system is still functional. And the next one is low. It won't cause any major breakdown of the system. So these are the types of severity.
Okay.
So now, what is priority? So priority is defined as the order in which a defect should be fixed. Higher the priority, the sooner the defect should be resolved. Defects that leave the software system unusable are given higher priority over defects that cause a small functionality of the software to fail. So next one is what are examples of defect severity and priority? If the software system is not working, it will be a high severity and high priority. So what is bug status? So defect status or a bug
Let's
status. Yeah.
can you go back to the slide 11? Yeah, here. So
Mhm.
software system, they're like, okay, examples. If it's low severity, so low severity, high priority. If it's low, why is it high priority if it's low severity? Or oh
Basically,
no, they're like 4 example. Okay, never mind. They don't go
yes,
together, right? It's not like
yes.
okay.
So what is bug status? So defect status or a bug status in defect lifecycle is the present state from which the defect or bug is currently undergoing. And the goal of defect status is to precisely convey the current state or progress of a defect or a bug in order to better track and understand the actual progress of the defect lifecycle. So the bug lifecycle is a new, then assign, then open. And open can be a duplicate, rejected, deferred, or not a bug. Then fixed, pending retest. Retest. If the bug is reopened, then we'll open the bug again and follow the same steps like fixed, pending retest, and then again retest, and then verify and close. So it's a bug life cycle which we are following while doing while using or testing the bug. So in this, when we found a bug or when we log a bug, so the state is new. Once we assign the bug to any developer or team, the state is changed to assigned. Then developers open the bug and it can be a duplicate and it can be a rejected because sometimes we logged a duplicate bug because we did not remember like which bug we have created earlier. So that is why we are checking in a duplicate. It's not a duplicate or rejected or deferred. Then follow the same steps like fixed. Then we can check the bug and then verify and then close.
So as a QA, we assign the bug to the developer, so the developer opens it. right? And fix it.
Yes,
And then it
developers
send,
change. Yes,
and then it send it back to the QA, to me, for example, to retest it, right?
yes. Once they fix a bug, they can assign to a QA to retest the bug, and QA can retest. And if it's not fixed, then again we'll assign to the like we can open a bug and then a same hierarchy we can follow, like open, then developer can fix a bug, then again we need to retest, and if it's fixed, then we can verify and then close. So what is a bug status? So when a new defect is logged and posted for the first time, it is assigned as status as new, then assigned. Once the bug is posted by a tester, the lead or the tester approve the bug and assign the bug to the developer team. And next state is open. The developer starts analyzing and works on the defect fix. Next one is fixed. So when a developer makes the necessary code change and verifies the change, he or she can make a status as fixed, and then pending retest. So once the defect is fixed, the developer gives a particular code for retesting the code to a tester. Since the software testing remains pending from a tester end, the status assigned to a pending retest or pending QA. Then verified, the tester retests the bug after it got fixed by the developer. So if there is no bug detected in the software, then the bug is fixed and the status assigned to verified. Reopen, if the bug persists even after the developer has fixed the bug, the tester changes the status to reopen. Once again, the bug goes through the life cycle. Then a close. If the bug is no longer exists, then a tester assign the status and it can be closed. And a duplicate, if the defect is repeated twice or the defect correspond to the same concept of the bug, the status is changed to duplicate. Uh, Next one is rejected. If the developer feels the defect is not a genuine defect, then it changes the defect to rejected. Deferred, if the present bug is not of a prime priority and if it expected to get fixed in the next release, then status deferred is assigned to such bugs, not a bug. If it doesn't affect the functionality of the application, then the status assigned to a bug is not a bug. So have you understand about the bug life cycle?
Can you go back to the, yes, here. If the present bug is not of a prime priority and if it is expected to get fixed in the next release. Oh, so the developer can choose to say deferred, even if the bug it's still there, but it's gonna be fixed in a different in the next release.
Yes, actually not a developer. Developer lead or manager can decide if it's a not priority or if it's expected to get fixed in the release, then they can change the status. Because once you log the work, the QA manager has or the another member like a team lead or any other member can check all the bugs, and then same is doing the from the development side, a manager, lead, or any other person can check the bug and they can change the status before going to the development. So next one we'll discuss about the Jira. Jira is an incident management tool which is developed by Atlassian Inc., an Australian company. It is a platform independent tool. It can be used with any OS. It can be a multilingual tool like English, French, German, Japanese, Spanish, etc. It supports MySQL, Oracle, pSQL, and SQL Server in the backend. It can be integrated with many other tools like Subversion, Git, ClearCase, Team Foundation Software, Mercury, Concurrent Version System, and many more. So we are using Jira as a bug logging tool or incident management tool.
So Jira, we use it to fix the bug or to find the bug?
No, Jira we are using to log the bug and track the history and all, because Jira is very popular in the market, and we are using to log the bug and developer can check and fix. And there are other tools as well, like Redmine or for to log the bugs. But Jira is very popular in the market. It's very easy to use, and it can be used by like anyone. Yes, because it has so many features.
And it can be used for like, just because it has like multi-language tool, so it can be used in different countries, and yeah.
So our next one is Bugzilla. Bugzilla is also incident management tool. So it is an open source tool used for issues and bugs tracking system. It is widely used as a bug reporting tool for all type of testing functions. It was written by Terry in TCL programming language in '98. Later, it was written in Perl, and it used a MySQL database. It can be used as a test management tool since it can be easily linked with each other test case, which other test case management tools like Quality Center, ALM, testing, etc. Bugzilla provides a powerful, easy-to-use solution to configuration management and application problems. It can dramatically increase the productivity and accountability of an individual by providing a documented workflow and positive feedback for good performance. So, if you want to try, you can check. You can download Jira or you can download the Bugzilla, and you can try to log the bug. So once you go through or once you write the test cases, after that you can check these other tools to log the bugs. Like it's for your understanding.
Yeah, so
Your
this has been my practice to get
yeah.
familiar with this tools. Okay.
So now the key features of Bugzilla. It is powerful and it has advanced searching capabilities. It supports user configurable email notification whenever the bug status change. Bugzilla displays the complete bug change history. Bugzilla provides interbug dependency track and graphic representation. It allows users to attach bugs, supported files, and manage it. It has integrated product-based granular security schema that makes it more secure. Next one is Quality Center. It's also a work management tool. So it's a history of Quality Center, like the commercial name first is test director, the version numbers mentioned here, owned by mentioned here. So after version 9.0, the HP take over the name or take over the quality center, and then HP has changed the name of the product, like it has changed to ALM. So it's what is the architecture of quality control. So we have a multiple clients, ALM clients. They can connect with the load balancer, and the load balancer is connected with the application server, multiple application servers, and then it is connected with the database and a site administration database. So these are things which we have discussed in the today's session, or we can say that
Can you
we'll
please
discuss about the
can you
yes.
please go back to that quality center? I'm not sure if I understand what's that.
Yes. Quality Center is also another tool. Quality Center, I think it's a paid version, like you have to purchase. But for Zira and Bugzilla, you can try it free. So next module is next session. Next module is test strategy and execution. So in this module, we'll discuss about the test execution lifecycle process, different levels of test execution. We'll discuss about the sanity and smoke testing, test batches, preparation and execution, testing, regression testing, bug leakage, and test design. So we'll start with the test execution lifecycle process. So it's requirement analysis, test plan, test design, the environment setup, test execution, test closure. So once we get the requirement from the SRS, so we'll analyze the requirement and then we'll create the test plan and then we'll design the test cases and then we'll set up the environment like it is like we need to test on QA environment, local environment, or any other environment. Then we'll execute the test cases and then we'll close the test. So the first one is requirement analysis. The very first stage in software testing lifecycle is requirement analysis, where the QA team studies the requirement. So in the requirement analysis, the QA team studies the requirement from a testing point of view to identify a testable requirement. And if there are conflicts or any requirements left unattended, the QA team interact or follow with various stakeholders like technical leads, business analysts, clients, and more to understand the requirements in detail. Entry criteria for requirement analysis is documents like requirement specification, application architecture, and well-defined acceptance criteria should be available. The activities are identify a type of test to be performed, testing priorities and focus are defined. Requirement or traceability metrics needs to be prepared. Identify a test environment details where test needs to be carried out. If required, automation feasibility analysis is performed. Next one is deliverable. It provides a list of questions with all the answers to be resolved from business, that is the testable requirements, and automation feasibility reports if applicable. Next one is test planning. So as suggested by its name, it is in this stage where the testing strategy is defined, which further makes it significant as well as the most prominent stage of software testing lifecycle. Due to its major function, test planning is also known as test strategy. In this stage, the QM manager lead determines the effort and cost estimate for a project and prepare the finalize the test plan. So once the test plan is completed, the QA team can start the test case development. So the basically test planning is we are determine the effort, like how many QA we have and how many QA we are going to test this, how much time it will take, what are things we needed for this. So all the things we have mentioned in the test plan. So the entry criteria for test planning is updated requirements documents and automation feasibility reports should be completed. Activities are define objective and scope of the project, preparation of test strategy for various types of testing, resource planning, and determine the roles and responsibility, test effort estimation, listing of types of testing involved in SCLC, selection of testing tool if required, and define if any risk are involved. And then deliverables are testing plan or strategy and testing effort estimation document is provided. So the next one is test case development. So this stage of the STLC involves the creation, verification, and rework of test cases in test script. Here, test case development activity starts once the test case planning is finished. The testing team prepares the test case as well as test data if any testing is required, which later is reviewed by the QA lead. So the entry criteria for test case development is the updated version of requirement document and automation feasibility report. And the activities are create test cases, automation scripts, review and baseline test case and script, create the test data if test environment is available. Deliverable is a test data, test cases, and if required, a test automation script. Next one is environment setup. To set test environment is a vital part of software testing lifecycle. It is one of the critical aspects of the testing process and can be done in parallel with the test case development stage. We can execute it independently. It basically decides the software and hardware conditions under which a work product is tested. It doesn't require testing team, and the testing environment based on company to company, maybe developer or customer. And for entry criteria is test plan, test data, and smoke test case are available. Understand the required architecture, environment setup for the test environment. Prepare hardware and software requirement list for the test environment. Set up the test environment and test data. So once the environment is set up, execute the smoke test cases to check the readiness of the test environment. So deliverables are test environment will be ready with the test data. A result of smoke test will be provided. Next one is a test execution. So the test execution stage fine it inception once the test cases are developed completely and the environment for a test is properly set. This is the most vital stage of all the SDLC as a tester not only tests the test cases here, but is also able to detect errors and bugs in the software. So in the test execution phase, we are doing the testing, a thorough testing where we can find the bugs or we can log the bugs. So in this stage, testing teams start executing the test cases based on a prepared test plan and prepare the test case in the Parashtra. So the entry criteria is test cases, test data, plan or strategy. Activities are test cases are executed based on a test planning. Status of test cases are marked like pass, fail, blocked, run and others. Documentation of test result and log defects for failed cases done. All the blocked and failed test cases are assigned bug IDs. The testing once the defects are fixed and the defects are tagged till closure. So, and the deliverables are provide defect in test case execution report with completed result. The guidelines for test execution is the build being deployed to the QA environment is the most important part of the test execution cycle. It is done in a QA environment. The test team size is not constant since the beginning of the project. Test execution happens in at least 2 cycles. Test execution phase consists executing the test script maintenance, and the reporting. And then exploratory tests are carried out since the build is ready for testing. So once the product is ready, all the development is done. So first of all, we'll do the exploratory testing to understand the functionality of the application. So next one is test execution tools. So also known as a test running tool. It is basically a tool used to run the tests. These tools require a scripting programming language in order to be executed, which creates a great advantage as they can repeat actions and loop for various data values, can take different route depending on the outcome of the test, and also can be called from other scripts giving structure to the set of tests. So tools we are using only when we are doing a automation only. So the characteristic of test execution tools, it captures test input while tests are executed manually, shows expected result in the form of a screen or an object for comparison when the tests are executed. It executes tests from stored script and optionally data files accessed by the script. It provides a dynamic comparison of screens, elements, links, control objects, and values while running the test. It performs the post-execution comparison, keeps a log of result of the completed test cases, synchronize inputs with the application of the test, measure the timing of test, and at the end, it sends the summary results to a test management tool. Another activity is closer, test cycle closer. Last but not the least significant stage of STLC, the test cycle closer is where a testing team meets and evaluates the cycle completion criteria based on a test coverage, quality, cost, time, critical business objective, and software. So here the team members initiate the discussion to access the features and the quality of test cases. So in this state, once all the testing is completed, then we can hand over the documents to the stakeholders, like a test plan document or like test closure activities, like how many test cases we have and how many we run, and how in this how much test cases are passed and failed. So these are things we are making a document and then take hand over to the stakeholders. Stakeholders, either it's a product owner or either it's a client. So the entry criteria for test cycle closure is test execution is completed, test case execution defect report is provided, and the activities are cycle completion criteria is evaluated on the basis of test coverage, quality, cost, time, critical business objectives, and software. Prepare the test metrics based on the parameters mentioned above. The learning of the projects are documented. Find the defect distribution by type and severity test results and analyze. A quantitative and qualitative reporting of the end product to the client. Share best practice for any similar projects in future. And the deliverables are test closure report and metrics are delivered. So we have a different levels of test execution. First one unit testing, second one is integration, system and acceptance. So unit testing is done by the developer. Integration and testing is done by the QA, and acceptance testing is done by the client or like on beta environment.
So it goes from the developer to the QA and to the customer or client, whatever.
Yes.
Okay.
Once a requirement is implemented, the developer can do a basic unit testing, like whatever they have implemented, they just check the implementation of the application. Then QA will start the integration and system testing, and once we have completed, the client just check the do the acceptance testing. So the unit testing, this is ideally our first level of testing software. How does it work? The specific line of code, distinct functionalities, and desired procedures are isolated and tested. These lines of code, functionality, and procedures are termed software unit because they are combined to make up the software. They can also be referred to as components of the software. The integration testing is this testing level involves combining all the components that make up the software and testing everything as a whole instead of individually as done during unit testing. Also from this level, tests can be split into functional and non-functional type. So why is the integration testing needed? So first, the integrated code could have been written by different developers. and need to be tested to ensure their correctness. By testing, we can identify and correct interworking defects, simultaneous operation defects, parallel operation defects, etc. So it's something like top-down, bottom-up, mixed, and Big Bang. So next one is system testing. It has to do with verifying the required operation of the software and its compatibility with operating systems. In other words, we test both the technicalities and the business logic of the software. We run functional tests to check what the various functions of a system do, and non-functional tests to check how those functions work. For instance, in functional testing, we check if a login feature responds when the user enters a password, but in non-functional, we check how long it takes the user to log in after password entry. So we have already discussed in the last session about the functional testing and non-functional testing. So next one is acceptance testing. This level of software testing is similar to the system testing, but here the test is carried out by some selected end users. This is the only software testing stage that is carried out by users. This stage determines if the software is finally ready to be launched to the general public. All the selected users give their various opinions about the operation of the software. They let the organization know whether the software meets their diverse requirements and recommended areas that may need to be improved upon. The acceptance testing can also be referred to as UAT, user acceptance testing. So there are two types of acceptance testing are alpha testing and beta testing. So testing like unit testing is set up the unit test scenario, set up the unit test cases and test data, set up the script where the unit test cases will run, find and fix the bugs, run tests until the system bug free. In the integration, we have to create a test plan, create the test scenario and test cases, make provisions for automation script, implement the test cases, record all failures found and retest. Another one is system, get the test plan ready, build the test case and scenarios, build the test data for testing, execute the test cases, and fix detected bugs and return tests. So in the acceptance, plan the acceptance testing, select users and introduce the software to them, execute the test, document feedback and errors, evaluate and draft a report. What is smoke testing? So it is a software testing process that determines whether deployed software build is stable or not. Smoke testing is a confirmation for QA team to proceed with further software testing. It consists of a minimal set of tests run on each build to test software functionalities. Smoke testing is also known as build verification testing or confidence testing. So smoke testing we are doing once the build is ready to check the basic functionality should be work, not a thorough testing, just to check the basic functionality of the or main functionality of the application. It is a mini and rapid regression test of major functionality. It is a simple test that shows the product is ready for testing. This helps determine if the build is flawed as to make any further testing or a waste of time and resources. So we are doing smoke testing so that we can save the time, because if we not consider smoke testing, so that time if the application is not properly working, so it could be a time waste for us, for all the team members. So that's why we are doing a smoke once the build is ready.
So we don't waste time and resources, right?
Yeah, because if we don't do a smoke testing, then we have to start the testing. And if we're doing the testing, if the application is not working properly, then the time of the resources definitely is the waste.
Yeah.
So that's why we are just verifying the build as a smoke testing, so that another member or the QA team can start the testing. When smoke testing conducted? So it is a process to make sure the build received from the development team is testable. It is often called a day zero check, and it is conducted the build at the build level. A smoke test can also be run as a part of build process in concert with a more thorough test when the build is released candidate. Work begins when the GUI interface and database are stable. Additionally, smoke testing is often conducted when new basic functionality is added to a system, but this is not an exhaustive test, such as unit or regression. It is just basic to check the functionality. So once we get the initial build, like build 1, 2, 3, 4, 5, 6, so we'll do a smoke test, then bug detected, smoke test failed, the build is rejected. And if the smoke test passed, the testing will start like a functional system performance and UAT. UAT is user acceptance
Oh,
testing.
yes.
So characteristic of smoke testing. So it turns quickly. The measure of quickly depends on the specific situation. Enables self-scoring as any automated test should do. Provides broad coverage across the system. It can be run by developers as well as part of the QA process. Expose basic errors in a new build, though it need not be exhaustive. What are the advantages of smoke testing? So it minimizes the integration risk, improves the quality of the end product, uncovers functional errors as well as architecture and component level design defect, help diagnose errors, simplifies the correction by associating the test with increment new builds and rebuild. So next one is sanity testing. It is a type of regression testing used in the QA. The main purpose of sanity is to make sure that the proposed modifications of functionality works as intended. If the sanity test fails, the testing team will reject the software product to save time and money. So in sanity testing, we are just checking the implementation of the functionality. If it works, then we'll start the regression. If it's not work, then we can reject the build.
So it comes after the smoke testing.
Yes, yes. When should you conduct the sanity? So once build is received after a number of regression, or if there is a minor change in the code, after bug fixes, the build is sent just before the production deployment. So sanity we are doing after the regression, not after smoke, after the regression. So first one is smoke, then we'll do the regression, and then we'll do the sanity
Okay.
before going to production. So benefits of sanity testing. It aids in the rapid detection of problems in fundamental functionality. Because no documentation is necessary for sanity, it may be completed in less time. If problems are discovered during sanity, the problem project is rejected, which saves the time for regression testing. The team focus is on validating the application functioning rather than the thorough testing. So it is usually done on a build when a production deployment is required right away, such as for critical bug patch. So the next topic is test suite preparation. So it involves the construction and allocation of cases in some systematic way based on the specific testing technique used. For instance, when usage-based statistical testing is planned, the test case allocation will be defined by the operational profiles created as the testing models. When coverage-based testing is planned, the specific coverage criteria would dictate the allocation of test cases. For instance, in control flow, testing the precise quantity of test cases defined by the quantity of paths for all the path coverage. So the test execution is like first we can create the test cases, then automation are optional. Then we'll create a test suite, add existing test cases to the test suite, create execution records, run the execution records, and analyze the execution result. What is retesting? So it is executing a previously failed test against new software to check if the problem is resolved. So after a defect has been fixed, retesting is performed to check the scenario under the same environmental conditions. During retesting, testers look for granular details at the change area of functionality, whereas regression testing covers all the main functions to ensure that no functionality are broken due to this change.
And finally, what is regression testing? Because I was wondering.
Yeah. Finally, we are now going to discuss about regression testing. So, it is a software testing practice that ensures an application still function as expected after any code change, update, or improvement.
Oh, okay.
It is responsible for the overall stability and functionality of the existing feature. So, when to apply the regression testing? So, it is applied under these circumstances. A new requirement is added to an existing feature. A new feature or functionality is added. The code base is fixed to solve defects. The source code is optimized to improve performance. Patch fixes are added. Changes in configuration. So why it is important? Test automation is a necessary element in a software development practice. Similarly, automated regression testing is also considered a critical puzzle piece. With a rapid regression testing process, product teams can receive more informative feedback and respond instantly. Regression testing defects new bugs early in the development cycle so that business do not have to invest in cost and maintenance effort to resolve the built-up defect. Sometimes a seemingly mild modification might cause a domino effect on the product's key functions. So, what is bug leakage? A bug leakage result when a bug is detected which should have been detected in earlier build version of the application. A defect which exists during testing yet unfound by the tester, which is eventually found by the tester and user is also called a bug leakage. So if we found a bug in the production environment that we can call a bug leakage. The next is what is a test design. The test design revolves around tests themselves, including how many will need to be performed, the test conditions, and the way the testing will be approached. According to ISTQB, test design also involves creating and writing a test suite for testing a software, but will require specifically and detailed input. After choosing the input value, QA team can then determine what the expected result would be and document it as a part of test case. Doing so will help give qualifications for passing and failing tests, allowing QA to quickly mitigate errors and refine their projects to achieve overarching goals. Yes, it's a very so much information in this module, so you have to go through with the carefully. Yeah, these are all the topics we have covered in this module. Have to go through this first because if you delay it, then it might be a chance to clear on
Yes.
your mind from your mind. Yeah. So right now you don't need to purchase any software. You just go through the open source tool, which is free and available in a Google in the market.
Okay.
And
Okay.
also, first you have to pick any of the web application or any of the application to create the test cases
Yes.
and then execute on the execution and then do the execution. And if you found a bug, you can just use the Zero Bugzilla. It's also an open source tool and it can be available in the market on a free basis.
All right, let's test your knowledge. Here's a question for you. What is the primary goal of manual testing? Option A, automate repetitive tasks. Option B, identify defects in software. Option C, improve user interface design. Option D, increase development speed. Take a moment to think. And when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
Module 9 is about test strategy and test execution. Usually, test execution is nothing but STLC, software testing lifecycle. So, for whenever we start with any test execution, as a QA, we'll be executing the test cases. Those test cases, before performing test cases, before that, what are the other activities we need to complete? Those things that will be in order. So that order, we'll call it as STLC, software testing lifecycle. So in this STLC, we have requirement analysis, test plan, test design, environment setup, test execution, and test closure. Generally, requirement analysis. In requirement analysis, the requirement documents we'll be getting from the business. Either we'll be getting from the business as a functional specification document. Generally, this
from the client, right?
Yes.
Or from the developer.
Not developer, from the client. So once we get the FSD from the client, we'll go through. We as a QA as well as developers also go through those requirement documents. Developers will perform their activities. We will perform our activities. Our activities, in the sense, we'll understand every requirement, and we'll create scenarios for that. Scenarios in the sense, suppose for the requirement, suppose you have a food delivery app. Generally, what might be a functional requirement for that? Can you guess anything? What are the requirements? You're familiar with food delivery app, right?
Delivery, yes.
Yeah. What will be the functional requirements? Requirements might be. What will be? I mean, in your opinion?
To be able to order food, I guess.
So for that, the requirement is user should see all the available hotels, and he should see all the food items.
The menus, yes, and restaurants, yes, true.
These kind of requirements. For that requirement, we'll be creating separate scenarios. Scenario in the sense, suppose we have a scenario example for the food delivery app. User should log in and check all the available hotels. So you can see, you logged in at around midnight. Few hotels will be open and they're available to serve, but at few hotels won't be available. So it should be listed to the user available, and so this is a kind of one scenario. For that particular scenario, you will be creating a test cases. That's what, initial phase is requirement analysis. What are the requirement analysis we'll be getting from the business? We'll go through all the requirement analysis. We'll be creating scenarios for that. Then we'll be generating a test cases on that. So first phase is requirement analysis. If you see that PPT, they said the very first is software lifecycle starts with requirement analysis. There you will, what you will do is, once you will get FSD, you will go through that, and what are the requirements you will understand, and if you have any requirements that you feel like required any clarifications, you will reach out to a business analyst. What business analyst role is, like he is a mediator, like from client as well as for us. So whatever your questions you will be having, you will be reaching to a business analyst, BA generally. So in few cases you can, in few projects, like you can directly interact with the client as well. But most of the cases you will be interact with BA. As you say, like if you have any conflicts or anything, you will be reach out to the various stakeholders like technical lead or business analyst. We'll see here, for every phase we have an entry and exit criteria. Entry criteria is like, for this requirement analysis, you should be like, if you start with anything, they should be you should have a preconditions for that. So for doing that, like for requirement analysis, you have a from preconditions, like that is called as entry criteria. For that, like if you start with some requirement analysis, before that you should require documents like requirement specification, application architecture, well-defined acceptance criteria. Like these should be available. Like you should be, suppose you think about food delivery app, you should once you start with requirement analysis, like you should the client should provide you some documents. Those documents is like what his requirements, what he is expecting from that application. Those things and all he will be providing to you. That is entry criteria. Activities is like you will be identifying the types of tests to be performed. Like he might ask you to perform automation also. He might ask me to perform security testing also. He might ask you to perform like mobile, other different platforms testing. Like you will be testing it, application supports only web or mobile. So different platforms it should support. So those are identifying types of tests to perform. Testing priority and focus. And even once you understand the requirement analysis, once you go through the, once you perform requirement analysis, you will be creating test scenarios, and then test cases you will be performing. So for you need to check whether all the requirements you have converted into test case. You require a requirement traceability matrix. So the purpose of requirement traceability matrix is you will be validating every requirement should cover at least one test case. That is the main purpose of requirement traceability matrix. We will be preparing that requirement traceability matrix. Generally, requirement traceability matrix contains the requirement ID. What are the test cases you will be creating? The requirement traceability matrix sheet contains, these are the two components it contains. You will be writing the requirement ID. To that, you will be writing the test case ID. Like you will be creating multiple test cases. Suppose for one requirement, login is a requirement, like user should log in. Even in login, they have a multiple user roles, suppose. So for that requirement, you will be creating a test scenarios and test cases. You will be mapping those test cases which you created to that requirement in requirement traceability matrix. And even we'll be performing these testing activities in different environments. Like usually we have different environment, in the sense, like as a testers, we'll be having a one dedicated environment, that is SIT. So the SIT are different environments. Usually they'll call SIT. So they have a test environment, like they call it as in different names. they can our environment, like our QA environment, we call it as different names. That is SIT or test environment. Those environments, like what are the environments we require to carry the test, right? That is SIT will be the UAT people, like business people. Before our product, they need to accept it, right? They will be performing some tests on that. So they will be doing the test in their environment. That is UAT. So UAT environment. There are different phases for that. So different environments for that. So we'll be doing in test environment. So these are the things, like identifying the environmental details or where the test need to carry out. If you required automation feasibility analysis, like generally we have a different automation tools like UFT, Selenium, Protractor. These are the different tools we have to perform automation testing. Like generally we have for this phase, deliverables are providing list of questions which all the answers to be resolved. Like if you have any questions to the requirements, right, that should be answerable, and you should get a clarification before start with going for the next phase. For requirement analysis, next phase will be test case creation. So, test plan. Next phase will be the test plan. So for that, you should be ready with all the requirements. Like you should know each and every requirement. You should be able to understand each and everything. So the next is in STLC, next phase is test plan. Test plan is like before you're moving to, you're performing anything, you will plan the activities. Like if this is the major thing, we'll be also involving as like we have a lead as well as we have a team. As a team, like test manager will be there, and QA lead will be there, and we are the ones like we'll be participating in the team. So we are the team members. So even we'll be providing our inputs in the test plan as well. The name suggests like whatever it's saying here. The name suggests we're test strategy and all we'll be adding in the test strategy is like how will we be testing the application, how will we complete the testing activities for that application. We'll be doing in this test plan, and they have a test mitigation. Like in between, you will be getting any hurdles like to complete the test plan, to complete the testing. Sorry, to complete the testing, you are getting some hurdles. So how you will overcome that? Those things and all we'll be doing in our. We'll be doing documentation in our test plan. Generally, our test plan there are different components in our test plan. The it contains features like number. It contains test plan contains like the number of QA people will number of QA people, and what are the roles of those QA who will be involving in the testing activities. What is the role? What are the futures they will
Timing
be?
also.
Yeah, timing also. Yeah, they will be. What are the futures they will be testing in the? What is the timeline we have to complete? On which environment we have to do, and like what and other things like. I can show you what and all other. Yeah, see here, test plan. See, resources planning and determination roles and responsibilities. So in this we can say like what are your role? Like suppose we have a team of 4 members. So what are the 4 members? What is the roles of each member? We can write it in our test plan. What is the scope of our testing? Suppose for this particular release, we have a food delivery app. You want to release like partial requirement, like you suppose you have a 10 requirements. Suppose you are completing in this sprint, like for this release, you want to complete particular requirements. So for this phase, what is your requirement scope and all, like what is the requirements you will be testing in this, those things and all you will be mentioning in the test plan. And selection of testing tools is if required. So generally, if you what are the tools we'll be using? So we have a few different tools, like for automation, as we discussed. For automation, we have Selenium, UFT Protractor. So different tools we have. So for that,
when you, I'm sorry, when you talk about testing tools, a testing tool can be an app that you use to find bugs in a software.
yes, even that includes, that is
that is a tool also, right? A testing
yes,
tool.
yeah,
Okay.
that is also, you can see that HP ALM we have one tool, Zira we have. So different tools we have. Those what are the tools you are going to use for that? How you will communicate the defect? Those things and all will do it in our test plan. So generally we'll, before starting any our test execution, after requirement, in immediate next phase is we have to provide our we have to create a test plan. So with that, like we will be planning everything, like how if you feel like any risk, you're not able to perform, you're not able to deliver the product, we are not able to complete the testing in within the time frame we define. Those things and how we can handle that, those things also we can include that in our test plan. Estimations, everything you will be doing in our test plan. You're clear with the test plan?
Yes, all clear, Anil.
Test case development. Like see here, for once we get the requirements, right? We'll be getting we'll clear with all the requirements, and now next phase is like we have created our test plan. Next phase is like we have to create a test case. Generally, creating a test case, there are different templates they will be using it based on your organization. Like the test case template will vary. Suppose in general case, you will be you're familiar with any test case template or anything, like test case development. Like we'll be doing our test cases, we'll be preparing all our test cases here, and in this phase we'll be writing all our test cases, we'll be storing in some repositories. Suppose we have a few other repositories, like example HPALM, I said, right? So once you complete all the test cases, you will be storing in that repository or any other. I'm suppose saying like example HPALM. In general, based on your organization, different tool you will be using it for storing your test cases. You'll be writing a test cases here in this phase. All the test cases I said, right? We'll be preparing here traceability, test traceability also. Traceability methods we'll be preparing. We'll check every time like all the requirements covered. At least one test case we created for every requirement. We'll be checking in this phase also. So in this phase, like the stages of software testing lifecycle involves the creation, verification, rework of test cases, and test script. So generally what you do, like you will write a test case, you will be sending to you will be doing a peer review, like with your teammate or with your lead also. If you feel like if they suggested some changes, you will be doing those changes, and again you will be sending for a review. Like you are doing here peer review. Like once you write a test case, suppose your login functionality is there. You have created a test case for that. Okay. Once you create a test case, you will be sending it, doing a peer review. Like you want to validate, like you want to check with your team or team member how it is those test cases work. If you want to check that, like it's kind of a check you're doing with them. So you will be doing with either your team lead or a team member also. So if they do any, if they suggest anything, again you will be include those changes, and you will be sending for a review again.
If you want to make a change, you create another test case, right?
No. In that only you will do. You require.
Oh, you can add to the existing one.
Yes.
So practically for any action, anything you do, you create a test case. Is that correct?
For every scenario, you will be creating a test case.
Yes, I understand.
The testing team will prepare the test cases as well as test data. If any testing is required, which later is reviewed by the quality assurance lead. See, whatever the test cases you will be preparing, right, that will be get reviewed by your team member or a team lead. Even test data preparation is also an important phase here. See, while preparing a test case, suppose you are preparing a test case for login. Okay, so for that you need to provide a login details, right? Login details, those things,
Yes.
We will be preparing our test data as well. Suppose after login, you're entering some text for restaurant name. So for that, you will be writing those kind of test data. Those are called as test data. So you will be using that, and you will be passing those input, and you will be testing the application. So what are the inputs you are passing? Those data is called as test data, and it depends. It varies to environment to environment. Entry criteria, as I said, like for every phase there should be some prerequisite to start with. So before I'm starting with any test case writing, I need to check updated version of requirement document and automation feasibility report. Generally, if I'm starting with any test case, so test cases, I need to go for new requirement version. That is, you have to take the latest one. If I'm working on the latest one, then I will be checking that avoid me to rework on same requirement again and again. Like if you got any new changes, you are not referring to a new requirement changes. Again, it will be a rework for you. The activities: create a test case, automation script if applicable, review the baseline test case and script, create a test data environment is available. See, these are the things actually. Even while writing your test case, if it is feasible for automation, you can mark it as you can do automation on the test case. You can suggest that it is automatable, so you can do that. So those things and all we can be those are the activities we cover in test case development. Deliverables are test data, test case, if required test automation script, environment setup. So test environment setup is like which environment you're going to test the application, and the platform also. Environment setup is one critical aspect of the testing process. You can done in parallel with the test case development also. Like parallelly, you can set up the test environment also. And usually, like test environment again depends on like application setup and all. It is also in which environment you will be testing. Suppose it's a mobile app, you need to set up that OS version. Like generally Android version, if you're doing it in Android, or you're doing in iOS, those kind of initial setup and all you can do. while parallelly you are doing with test case development also. And executed independently, it's basically decided the software and hardware conditions under the work product is tested. Test environment is set up, does not require a testing team. Test environment based on the company to company, maybe developer or a customer. Generally, like when we are testing it, right? Suppose I have this website, I'm showing the PPT. So this environment and all, it is set up by developers. So we can't create this environment. In this case, we can only give our inputs, like we'll be passing our inputs only. This is done by developers or a developer team lead, or those and all. They will decide. They will be preparing the test environment, test case development, test plan, test data, smoke test cases are available, entry criteria. Okay. Generally, before this, we'll see what is a smoke test and sanity test. Smoke test is generally like before you're running any your plan, you have 100 test cases. Your environment is ready. Before that, what you do is you do the basic scripts you will be running, and you will check whether you can able to proceed with testing or not. You will be doing a basic test. The basic test is called as smoke test. Before you start with any your test execution, you'll be running some few tests, like login is working, you're able to log in with a particular user role, and that environment which you're running, that is stable or not. Those things and all, you will check it in smoke script, smoke test. That is called smoke test actually. So entry criteria. Test case development entry criteria is test plan. We'll be completing test plan. We'll be providing test plan to the like it is also a deliverable actually. Test plan is also it's one of the deliverables to the client. And test data and smoke test cases are available. Activities. What are the activities it covers? Under the required architecture, environment is set up in test environment, preparing hardware and software requirements listed in the test environment, set up the test environment and test data. Once the test environment is set up, executing the smoke test cases and check the readiness of the test environment. That's what I covered, right? Like before you're performing your complete test execution, you will be performing a smoke test. You check that that environment is ready, you can execute all other test cases also. The basic test is called as smoke test. See, deliverables. The test environment will be ready with the test data. Results of smoke scripts will be provided. Test execution is like, before that, I want to show you like how the test case template is. If you are writing any test case, the particular test case template. Like suppose I'll go Google it. I want to show you how the test case template will be.
And to write those test cases like this, are we using like an app, or we're just doing this like in Excel or something?
Yeah, we'll be writing in Excel. What we do is generally we'll write in Excel, and depends on your organization as well. See, in few cases, if you are using HPLM or TFS, those in TFS, you even both the tools it will support. You can export whatever the test cases you have written in Excel, right? You can import those test cases to ALM or TFS as well. TFS is another tool. There you can write the test cases, and you can monitor your testing activities. Also, you can do it in TFS. Sort of explaining you, I thought of take you to sample test case. It will easy for you to understand what test case contains. I'll walk you through that test case creation. What are the fields it contains? I'll walk you through all the test case components of it. and you try it for that, and we'll do a review on that. So
Okay.
it will be easy for you to next time to understand and go through that each test case, like how you will be preparing out what the requirements we have. So it will be you'll be understanding more. As we said, like the different when the in which environment we'll be testing that performing that execution and all, we'll be checking here. If you find any defect, right? You're familiar with defect bug differences, right? In this stage, like if you while executing, if you find any defect, you will be communicating to your developer, but you will be raising in a particular tool, which I said, right? TFS or ALM or any tool if they are using Bugzilla. These are the few bug tracking tools. They have many in the market. Depends on organization. Again, which organization you are associated with and what the tools they are using. It depends. In general, like suppose we are considering in ALM. In ALM, like if you find any defect, so how you will be communicating to the developer? You will be writing the defect description. Suppose example, like while you are performing test execution, you find a defect, and how you will be what inputs you will be providing to the developer is generally like in general sense, like you can you think about it, like what informations do you provide to the developer?
Um, maybe where I found it, right? The location, what type of defect it is, and how can it be? No, yeah.
Correct. Yeah, you're almost there. So that like how you will be like you will be telling like where it is located. Suppose in application where it is, like in login page, or after logging in you're performing some particular step, you're ordering some food. So since I'm taking this food tracking food app is like you are most familiar with that. So suppose after login you're searching for any restaurant. Restaurant is available, but you're not able to click on that. If you're clicking on that, you are getting some exception. This is an example. Like when you're communicating this defect to the developer, you will be providing steps to reproduce. Like what are the actions you perform when you get this defect? Those details you will be providing to the developer. And which environment? Suppose it is in SIT or it is in other environment. Like we have general, we'll be having stays, SIT, integration. So there are the different environments we have. Just environment is like your application is hosted, right? See, it is if it is hosted in SIT, you won't see any difference like environment. You only test the application. So environment is like which environment you are testing. So you find it in your test environment. So you mention it, then each the environment you find it in, you mention it as test environment. And what are the inputs you have provided? That's a major thing, like to reproduce any defect. You because of you provided this input only, you find the defect. So you have to capture those details as well while providing defect description to the developer. So test execution entry criteria. As I said, for every phase there will be an entry and exit criteria. Entry. So like before performing any test environment, you have to check test case data, test plan, or test strategy. These are entry criteria. And activities are test cases are executed based on your test planning, and status of test marked as pass, fail, log, run, and other. Suppose what are these phases? I mean these statuses are while you executed. Suppose you have a login test case. You have executed. You mark it as pass. So you provided your login details. Okay. For that, after you enter your password and everything, you are able to log in. Then you pass the test. Test cases pass. You are not able to log in, and it's not the system is not allowing you to log in. So you keep it as fail and or a blocker, since the login functionality is only not allowing you to use the app actually. So if you log in only, then only you can able to use the application, right? It's blocking you. You're not able to perform any other activity. So you can tell it as a blocker. And again, the blocker is also like it's a showstopper. You're not able to perform anything. So you mention it as a showstopper and keep it as high priority. Those things and all you can do it in test while performing the test execution. The documents of test results and log the defects for failed cases is done. All the blocked and failed test cases are assigned bug ID. See, whenever you're facing that login issue, you will be creating a defect to the developer, which I said earlier. Like you will be providing all the defect details and all, and you will be raising in particular tool like defect tracking tool. Suppose if I'm using Bugzilla, there I'll be adding all the defect description. Once you create a defect, their unique ID will be generated for a defect ID. So bug ID will be created and it will be assigned to the developer. So for all the failed test cases, you have to create a defect. Retest once the defect is fixed, right? You will be retesting the defect. It will be assigned to you. I'll tell you the defect life cycle also. When you
yes, I remember this.
Yeah, whenever you create a defect, right, it will be new state and it will be open. Suppose you find a defect, you assign to me, it will be new and open state. Once I fixed it, and I will keep it the status as ready for retesting. Okay, and I will be assigning to you. It will be in retesting phase. What you do, you will be you will be retesting it. That is called as retesting. The defect, the functionality, you will be retesting again. The failed test case will be there, right? You will be retesting again. So the particular test case is re-executed. You feel the defect still exists. Then you will be reopening the defect, and it will
back.
Yeah, and assign it back to me. What I do again, I'll go through the defect and I'll fix that. If you feel like defect is fixed, there is no defect, there is no like functionality is working absolutely fine, then we'll be move to fixed and closed. Generally, in few cases, what I do, like in my developer perspective, what I do, like I defer the defect. Deferring a defect is like, see, different. Why I'll do is when you assign a defect to me, right? I can defer a defect. I can mark it as duplicate. I can reject the defect. I can say it is not a bug also. So generally, like if I'm deferring a defect, see, deferring a defect is like I will be take care the defect in next release. I'm postponing the defect fixing to next release. In that case, I can move it as deferred. In some cases, like the inputs you provided to me, I'm not able to reproduce the defect. Okay. In that case, I can keep it as rejected. I can keep that straight away. I can reject the defect, mentioning that I'm not able to reproduce the defect in my environment. Whatever environment you specify, that environment I tried, I'm not able to reproduce the defect. Sorry, I can't fix it. So I can keep I can change the status to reject. And if I see the same defect again, I'll keep it as duplicate. And same kind of defect I reopened once again. So I'll keep it as defect. And in other cases, like it's not at all defect only. It's a feature is built in such a way that it should work in that way. Like we thought it's a defect, but the future works in that way. It performs in the same way. The functionality works in the same way. So it is an expected behavior. Then we put it as a not a defect. We can say it as a not a defect. Documentation of test results and log defects for failed test cases we done, and we'll be retesting our defect once it is fixed. Suppose you assign me the defect, I'll assign it to you back. I fixed it and I send you back. So you will be performing retest. Defects are tracked till closure. So you will. It's your as a QA, it's our responsibility to track all the defects. We will be tracking in tool like defect tracking tool. So there will be we'll be tracking what are the open defects we have, what is the status of those defects. Since it's our responsibilities, so even in few cases we can send status mails also for what are the status on these defects and all. We can send it to a developer. Deliverables provide defect and test case execution report with complete results. Generally, we'll be providing those results, like we'll be sending in few cases, like you will be sending in daily basis, like what are the test cases you have completed today and what are the defects you have found till today and what are the defect status. Everything you will be sending to your lead or your manager, or like in weekly basis also you can send your test execution status. Will begin by deploying the quality assurance environment in most important parts of test execution cycle. Test execution done in QA environment. See, as I said, we as a testers will be having our own environment. We'll be testing each and every feature in our environment. Generally, the developers, they deploy the code, they'll perform the unit test in their environment. You're getting right? We have a different environments, as I said, right? Developers, they test it on dev environment. As a QA, we'll be performing our test in test environment. UAT people, like after our testing also completed, there will be one more check from client, right? That environment is called UAT environment. User acceptance test, UAT environment. They'll do it in their own environment. So they'll be, before accepting the product, they'll be doing UAT. So once it is done, they'll move to the production, that code. So it will be available for end users. So test execution, we will be doing in our environment only, test environment only. Since why environment specific is here, in few cases like few defects we find it in test environment that won't be not able to replicate in developer environment. Reason is like in developer environment they might have few other softwares installed or few other setups they might do, right, for coding and all. Might be a reason like we won't be able to perform. Generally, we won't we won't perform any testing in developer environment. So strictly we'll be doing in our test environment only. The test team size is not constant since the beginning of the project. Test execution happens in at least 2 cycles. Test execution phase consisting of executing the test script maintenance, and reporting. So generally, what you see is like while you're executing the test cases, you feel some requirement gap. Even though your lead or your teammate has reviewed it, while executing it, you feel something you can add, you can enhance the test case. In such cases, you can modify your existing test case and you feel that gap also, you can fulfill that gap by enhancing those test cases.
Hey there, want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
See, here we said like test requirement analysis, test plan, test design, environment setup, test execution, and test closure. It's a test execution lifecycle process is like we can call it as a STLC, software testing lifecycle. So under this we have different phases. While performing testing activity, we'll follow different phases. Initially, we start with requirement, then we'll prepare a test plan before starting a test execution or testing. Then we will move to test design and test test design and test environment setup. Environment test up and test design we can do it in parallel, and test execution will perform and will find any defects and will be assigning to a developer. And before doing that, we'll performing in a smoke test and all will be performing while before start with any test execution and all we have discussed till this point we have discussed. I'll directly move to the slide number 16. See, we are at different test execution tools. There are different test execution tools like we said like HPL, MR, TFS we have a different tools in market, a test drive. So what it do is like you will store your scripts, you run it once, and you can reuse it again. The same script you can copy it into a test. You will be creating a test instance, and you will run it, and you will store your test results for the particular run instance. And you will move if you're going for next release, you will be doing regression. So you will copy the same script to the regression suite, and you will be running it. Right? It all depends on your the tool which you are going to use. So we have a different even we can automate the test script using Selenium or UFT, and we can re-execute the step. We can keep it in loop, and we can run in a test loop, test suite. We can run it in a single shot. It's all about test execution tools. See, characteristics of test execution tools. Capturing the inputs, like the main purpose of executing test cases in using the text execution tool is you can capture the test results, like whether it is pass or whether it is a fail, it is a blocker or anything. What are the status it is, we can capture the test results, and we can see it for other future purpose. Like if you're moving to another sprint, and like if you want to see if you want to share the test results also, like you can import the test results and you can share it across your team. So that flexibility is provided to you if you are using any test execution tool.
Yeah. Okay.
See, storing an expected result in the form of screen or object and comparison when the tests are executed again. It executes the test from stored script and optionally data file accessed by the script. Provide a dynamic comparison of screens, elements like control objects, values, running tests. It performs post-execution comparison, keeps a log of results, completed test cases. Synchronize inputs with application under test. Even you can measure the test execution time also. See, I said right after you're completing your test execution, you can send a email. You can send a complete test execution report. You can import the complete report, and you can send it to your share it to your client or team. What is the status of test execution and all. So those are the features which is available if you're going to use any test execution tool. See, test cycle closer is we can call it we can test closer. We'll prepare a test closer document. Like once you complete your test execution, right? We'll be summarize all the test summary, like how many test cases we have for the particular sprint or of a particular run, how many we have completed, and will be how many we have ran it, how many got failed, how many got passed, and what are the complete status we can provide it in a test closure document. The test closure document will be sharing once all of our testing activity is completed, and we'll be going to send this test closure document to our client actually. This test closure document is a one of deliverable we'll be mentioning in test plan.
So wait, the test cycle closure, it's still the QA team that performs it, right?
Yeah.
Okay.
See, as I said, like every phase has an entry and exit criteria. For this phase, is entry criteria is test case execution is completed. Test case execution and defect report is provided. Activities. Cycle completion criteria is evaluated on basis of test coverage, quality, cost, and time, and critical business objectives and software. Preparing a test matrix based on the parameters mentioned above. Learning of projects are documented to find the defects distribution by the type and severity type. Test results in analysis. A quantitatively and qualitative report of end product to the client. Sharing the best practices for similar projects in future. Test closure deliverables, test closure report, and test metrics are deliverables. See, for these like test metrics, as I said, like we have like if we are we can test closure documents. You will be providing all your inputs and how many test cases we have and how many we have got executed. What are the like blockers? What are the challenges you face? Even you can include those, and you can keep it as you will be sharing to your client actually. So even you're facing any challenges, even you for the similar projects, if you provide a test closure documents, it will be a reference to for other projects as well. Different we have completed STLC, software testing lifecycle. So there's a complete there's a STLC we have completed it. Now we move to different levels of testing. This is the one part we have completed. So we are moving to different levels of testing. There are different phases in testing. So unit testing, integration testing, system testing, acceptance testing. Any idea like what is unit testing? Like okay, fine, no issues. Unit testing is like we'll be testing individual functionality. Like I'll scroll it here. See, this is ideally
yeah.
This is like how it here is specific line of code and distinct functionalities and desired procedure isolated and tested. This we can like if you developer they will implement some piece of code and piece of functionality we can say, and they will provide it to you. You will be testing that particular unit. So like it is you can say it as
unit by unit. There's no like it's not in a bulk or in a group or anything. It's just like one by one.
Yeah, okay. Yeah. So they can also be referred as component of the software. Like each and every feature they'll be sending to you. Suppose we are talking about a delivery app, right? You've seen that login is a feature. After login, user should navigate to that list of restaurant page. You enter your password, username, and password. You clicked on that, and it should navigate to login. Home page, landing page. There you can see all the restaurants list and all. You can provide further. You can provide more inputs, and you can filter, and you can order any of the from any of the restaurant. So suppose like I have implemented login feature. So I'll be providing you for testing. Like I have completed login feature, please test it. So like it is an independent component. Like, so that's what. Now, if you go for integration testing, like now I have completed the login feature. I'm able to move to landing page. From landing page, now I'm able to search for a restaurant and able to select an order and able to provide all my location and all. This is now next component. Suppose the login is an independent component. Now some developer has implemented this login feature. Another developer, they implemented some other feature like filtering a restaurant and ordering any of the food product from that. And this is the future here. Another developer implemented. The communication between the two things we have to see, right, when you are integrating it. So
if they speak with each other, okay.
Yeah, sorry.
Yeah, if they just like these features, they talk to each other, if they communicate. Yeah.
Yes. After combining each other, you will be testing it. So it's after combining it, you see like there's a I mean there should be a communication, right? Once you log in and you need to navigate page, and from there you will be filtering and you're ordering any of the product from any of the restaurant, right? It's a complete thing, right? So there should be a communication. So after you will be validating like the complete flow of the application. I mean combining these two components. This is called integration testing.
Okay.
This testing level involves combining all the components that makes a software testing everything as a whole instead of individual, as done during the unit testing. As we said, like it's a two level. I mean, combined of components. So the first integration code could have written by different developers need to be tested and show this correctness. Also, this level can split into functional and non-functional types. This integration testing is needed. See, even if while testing it, we can see data communication between the two products. Two components. Like if you logged in some user might have some specific offers. When you log in with that specific user should able to see all the offers in that particular restaurant if he selects. Like data communication between two individual functionalities should integrated and it should work combinedly.
Together, yeah.
Yes. Top down, mixture, big bang. I'll show you. I'll tell you. There are 4 approaches for that. Like if you combine each and every individual component you're combining, right? They're saying like they have a different 4 approaches for that. So first approach is top-down integration testing. The rule of thumb when applying the top-down approach is test higher units before checking the lower units. In other words, performer has to test from top to bottom. Like it depends like from top to bottom. Like major higher functionalities you will be testing first. Like suppose based on the priority. Like if you're testing login functionality, it's a high priority, right?
Sure.
Yeah. So it will be like from top to bottom. Someone will be doing bottom up, integrating the small components like lower components first, and then they'll go for higher components. Like suppose we can say like individual components like filtering it restaurants, seeing your orders. They are like first they are combining that, then they're integrating with login. So the bottom to up. So this is one approach. Big Bang approach is like Big Bang integration testing refers to when all elements are tested concurrently in a single phase. Big Bang model is also applicable when validating a small applications The top-down or bottom model can be bypassed. These modules are programmed, combined, and tested together. See, like what their Big Bang is saying is that, like if you have individual components and you will be testing at once, all the modules you will be integrating, you will be testing everything at one shot. Like you will be complete flow of the application, you will be testing it in one shot. Like there is not individual component one by one component you will be adding and you will be testing. It's not like that. It's like your complete application will be each all the modules will be deployed and you will be testing complete flow of the application. Mixed integration testing, like available modules are being tested whether they belongs to higher or lower code line. This means that no priority is given to either component by performance. Unresponsive models are simulated to determine how well the available code will work when code is completed or combined. Like they're saying, like they won't in mixed integration testing, also called as sandwich testing. So what they do is they won't follow the flow or low code line or high code line. Just they'll combine any of the modules and they'll see randomly they'll combine and they'll see like the code is working or not. Like they will be integrating the code. Usually these integrations and all we won't involve in this actually. So in high level we'll be getting a modules, we'll be they'll be testing it and any at any point of time. So you see first a login component is not implemented. So they implemented only restaurants, filtering a restaurant, selecting veg or non-veg, or I mean, you're selecting any of the restaurant, and from there you're selecting type of the product you're going to food you're going to order. Like these are the things. Like there is no priority for that. The individual component they'll select it and they'll combine, and you will be testing it. Okay, we move to the system testing. Like we have a different levels, right? One minute, I'll take you to that again. Yeah. So we have completed unit testing, integration testing. Now we are going to see what is system testing. So like system testing is we will be testing the complete application as a whole. So there is now we are saying like in integration testing, we will be integrating individual components, and we have seen different approaches like in integration testing. We've seen like four approaches in integration testing, like Big Bang, top, bottom to up, or top to down, or mixed. So in integration testing, like individual components we are combining, but in this case, we'll be testing system as a whole. Complete system we will be testing in system testing. Like see, system testing has to done with verifying the requirement operations of the software and its compatibility with the operating system. In other words, testing the both technicalities and the business logic of the software. We can run the functionalities to check what the various functionalities of the system do, and non-functional testing to check those functions are working. For instance, functional testing will check if the login feature responds when user enter a password, but non-functional testing will check how long it takes the user login with after the password enters. See, as I said, like in system testing, we'll be testing system as a whole. Like we'll completely end to end we'll test the application. Like if in system testing we'll be doing both functional testing as well as performance testing. Suppose if non-functional testing, like non-performance testing is an example for non-functional testing. So they'll see like suppose you have a login screen. When you log in with a particular user, you'll see like whether it is navigating to the landing page, it's populated with all the restaurants. This is a one functionality, it's a functional testing. We'll be doing that. But in non-functional testing, they'll see like how long the user is displayed with the restaurant page after login, and how much time the user waited for to page to load. So those and all we will be calculating. We'll be doing both functional as well as non-functional activities, and we'll be testing the system as a whole, like complete application you will be testing end to end in system testing. And moving to acceptance testing is like it will be done by end users. Like we'll be till this point, like we'll be testing, we'll be doing that. But acceptance testing will be done by UAT people. Like from business, there will be some business users. They'll be doing this testing before accepting. It's moving to higher environment. So the level of software testing is similar as system testing. They'll also do the same end-to-end testing, complete testing they'll be doing. But here, the test is carried out by selected end users, that is business users. Like business users, they know the complete functionality of the application. So they'll be they'll be having their own scripts, they'll be executing the scripts, like we'll be writing our scripts, right, while testing. The same way they'll be preparing the functional scripts and they'll be running and they'll be validate the complete functionality of the application. Software is finally ready and to be launched to the general public. All the selected users give the various options about the operations of the software. They'll let the organization know whether the software meets the desired requirement and recommended areas that may need to be improved upon. Acceptance testing can be performed to the user acceptance testing, that is UAT. Usually I said, right, there are different phases. Like last phase is UAT. Once after your testing is completed, all the defects, everything is more completed, you will be moving the code to UAT, the last level. There, business users, they'll be performing the testing. And suppose you are the business actually. Suppose you have given a requirement. Like since we are talking about the restaurant app, so you have that requirement. So you know that more functionalities, like you will be acting as the end user. You see that all your requirements are fulfilled and everything is completed. All the requirements are meeting the expectations. So if you need any modifications or anything, you'll be you will be telling that those you can raise it as a defect, UAT defect, and you can fix it that if it is a minor or anything. If it is a major requirement, it again depends on your team actually, how they're going to fix it. They can take it as a user story for next sprint. They'll be fixing it in next sprint, or they again it depends with they will be discussing with the client how major it is, how it is impacting. If any new changes, like you feel like some requirement is not fulfilled, so what you do is you will raise the concern, like in form of defect. They'll that development and testing team, they'll look over that, and they'll feel like if it is a major change, it requires more time. So they'll discuss with you and they'll come up with a plan, like they can do it in next sprint or they can work it on the same sprint. See, they're given like unit testing, integration testing, system testing, acceptance testing. Set up unit testing scenarios. Create in integration testing, create the test plan, get ready test plan. Acceptance testing. Let me tell you. I'll explain you this first. What are the phases we completed in this? See, all the phases we are completed. If you don't mind, can you repeat whatever we have discussed till unit testing to acceptance testing, so I can see like your understanding. If anything.
Yeah. So yeah, that is good. So in unit testing, we test unit by unit, so part by part or one by one. In integration testing, we actually test if one feature speaks well or work together with a different feature, and we just integrate different features, right?
Yeah, correct. We'll see the data flow between the two components, two individual components. Yeah.
Yes. And then system testing, we test the whole thing as a whole, the whole system.
Yeah, you will be doing both functional and non-functional. Yes,
exactly. Yes. So we'll be testing functional and non-functional. As an example, for non-functional will be the performance testing, which would test how long, how long would take for the page to load, right?
Yeah, so that's an example. Like you will see like how long it comes under non-functional testing. Like you will see those aspects as well, both functional and non-functional. Functional is like you'll see like you're able to log into the page and all. You will see, and in non-functional you will see like other aspects like performance testing. Non-functional is a non-functional testing example. Performance testing. You'll see like how soon that page is loading, like time of like after clicked on login, how it is immediately the page is loading. Those things and all you will be checking in non-functional thing. Yeah, continue. In this space you will be checking all the business user will check all the requirement are implemented and it is working fine. So it's like a business validation. Various options about the operation of the software. There are two types of alpha testing and beta testing. I didn't cover this, sorry. There are two types of accepting testing, alpha and beta. Like alpha is like it will be done in in your own environment, in your place, by the business people. And beta testing is like it will be done at business place and done by business users. You generally see like some softwares they will be releasing beta versions and all. You see like any of the product, if you see any if you see the Android also, if you go and check it in Android, there will be a version called beta. Like it's a with that they will be gathering it will be allowed to your public. They can use it and they can provide the feedback as well. Any improvements or anything, they'll be they'll see like for limited audience. They won't it will be allowed for limited audience. They'll try it and they'll say their opinions and all, any changes or anything they can they'll be considering in these phases actually. I'll come to this slide. Um, I'll come to this slide. We'll move to the next topic. What is smoke testing? Any idea?
Okay, so smoke testing, it's a general testing that it's performed right before you start.
Correct.
To start the whole process of testing, just to make sure that you're on a
able to
right
perform.
path.
Yeah. See, the main motto of the smoke testing is, if you have 100 test cases, you're running the like no need of before starting it, you will check system stability. Like kind of you start with those to execute those test cases. You see like whether you can able to proceed with executing all the 100 test cases or not. You will be doing before that. You will doing is check, like that check is called smoke testing. Like you run the some basic things and you will see like system is stable and we can able to proceed with remaining testing. You with this smoke testing only, if you perform smoke testing right, you feel like system is not stable, you are not able to proceed with any like suppose I'm the developer, I release the new build. Okay, you have some 15 to 20 test cases. So before before you perform the executing those tests, you'll run one smoke script. Like if you identify some smoke scripts and you will be running it, you see like there is a some gap. Like suppose you are running something, its functionality is not working, you are not able to proceed. So like there is some basic things is not working. What you do is you directly reject the build, saying that the basic functionalities is not working. I'm not able to proceed with I'm not able to proceed with my testing. So like no need of executing all the 20 test cases and raise the similar defect. You getting?
Yes.
So it's the main purpose of smoke testing is that. So like basic check. Initially, you're able to proceed with your remaining executing all the test cases. You will just kind of check whenever you will get a new build, right? Whenever you start with testing, you will check that everything is working fine, so I can proceed with my remaining work.
Got it.
See, smoke testing.
I'm gonna write this down.
Smoke testing is a software testing process that determines whether the deployed software build is stable or not. As I said, I'll be deploying a new build, but you have to check that whether build is stable or not to perform your executing or your remaining 15-20 test cases. And as I mean saying example, so performing remaining activities. Smoke testing is confirmation of QA team to proceed with further testing, software testing. It consists of minimal set of tests run on each build to test software functionalities. Smoke test is also known as build verification testing or compliance testing. You got that right? See, it's in smoke testing, you won't run all the test cases, right? You have a selected test case. Like suppose you're doing a you're doing some that we'll take example as food delivery app only. You logged in and but the restaurants are not populating some you're filtering it, but the restaurants are not displaying and it's showing as closed. Even that the tough time frame is also moved out. Like it will be moved in restaurants shut down in some particular time, right? Even that particular window also, you are not in particular window, closed time window. Even that time also it was showing as closed. Or are you seeing that some issues? So like you won't run all the test cases, just you log in and you see, okay, these things are not working. I'm not able to perform remaining activities. So it is a minimal test case, like 1 or 2 test cases you will execute and you will confirm it. It is a minimal and rapid regression test of major functionalities. It's a simple test that shows the product is ready for testing. This helps to determine the build flow as make any future testing a waste of time and resources. Generally, like main benefit if you run 2 test cases and you said like build, you rejected the build. Build is not stable. I'm not able to proceed. It's like I mean, if you see the advantage, like you no need of running all the 20 test cases. Just you ran the 2 test cases. It's saved your time and resources time as well. Like for suppose you're for running those 20 test cases, you required 2 team members to complete that. So even you I mean, you saved the time of complete your your team time also you saved it. When the smoke testing is conducted, like generally at what point we'll do, as we discussed, like any new build, like we seen right till now we discussed any new build is deployed and want to test you want to proceed executing your test cases. Like the point is like any new build is deployed. Smoke testing is a process to make sure build received from the development team is testable. It oftenly called day zero check. It's conducted at build level. A smoke test can also be run as part of build process in concern with more thoughts, more through test when the build is released candidate. See, generally what I said, like if you got any new build, you will be performing your smoke script. Like initially, it's this they say it as your like your test execution. Like our testing phase is started. Okay, we have to complete all our test execution. Development is completed. They moved our code to test environment. All the functionalities is ready. We have to validate it. For doing that, like the day zero, like we have 15 days of time. So we have to complete all our testing activities and we have to provide our test summary report. So the initial phase, the build is deployed, right? The initial phase, the day zero, like you before you're starting your complete execution, like initially the first day, you'll like initial first step is day zero step is you'll be checking the you will be validating the build. It's not but it's not an exhaustive test such as unit or regression testing. You might familiar with the regression testing. What regression testing? Not it, right? Okay, okay, fine, no issues. We'll be covering these keywords actually. If you see it is a regression testing. In testing as a QA, you will be listening these keywords actually. These are the major keywords.
Yeah, I feel like I've learned about it, regression testing. I just can't remember what it is.
Yeah. So these are the keywords you usually came across. You will be coming across came across these words while you're performing day-to-day activities as a QA. This one smoke testing. These are the major things you will come across daily. See what I said. Like you will be rejecting the build, right? When you perform the image, if you see initial builds, build 1, build 2, build 3, build n, like you will be performing a smoke test. If you find a defect, you'll be rejecting the build, saying that these are the functionalities not working. We are not able to proceed with our testing. So smoke test is passed. If smoke test is passed, then you will be doing your functional testing, system testing, even performance testing. Like these are the different phases you can, like the build is stable and you can perform all these phases in this. Like you can, for all the phases, you will be functional testing also. And the system testing. System testing, we'll see like we'll be testing the whole, right? Even performance testing, it comes under non-functional testing. So in UAT, in every phase, we'll be validating that build, whether we can able to proceed with testing or not. Now you characteristics of smoke testing. You will run expose the basic errors in a new build through it needs not to be exhaustive. Can be run by developers as well as part of quality assurance process. Provide board coverage across the system. Enable self-scoring as any automated test should do. Run quickly. The measures of quickly depends upon the specific situations. See, generally the developers also they'll have unit test cases. They'll be writing unit test cases. Even the developers also can do. Even we can also do. What the developers will do is like whenever we are they're deploying any new build, right? Whenever they deploy a new build, they will trigger unit test cases. They will be creating a unit test cases. They'll see the basic functionality is working fine or not. Even they will also do, even if you are if you have any small automation scripts, right? You will be categorized as a smoke script. Whenever any new build is run, new build is deployed, it automatically triggers smoke scripts in automation. If you implemented any automation scripts, those scripts will get triggered and it will check the correctness of the build. Like it's a quick thing, right? It's hardly 1 or 2 test cases. You can get it in less than 5 minutes or 10 minutes based on the test case you ran. So with that report, you can, if it is the automation report or manual report, with that, if you are using any execution tools, even you will run it and you'll see like the test case is failed, so you will attach that some test execution report, and you'll send it to your mail team like it's not like build is not stable, we are rejecting the bill. For that, like these are the phases. Actually, we can say like these are the different characteristics of smoke testing. You tell me the advantages, like how far you seen that scenario, right? What is the main advantages now? What is the advantages you feel? Suppose I given you a build, you need to test it, but the build is not stable. You rejected the build. What's the advantages? Like doing smoke testing.
Oh, well, look, just because well, one of the advantages would be I cut it on time, like in the right from the start.
Yes, yes. The other thing is
Right.
like, yeah, your time and your team, like complete team time, you will be saving it. Like time and
Saving time, yeah, and resources, right?
yes, yes, resources time. See, we'll go for it. Minimize the integration risks.
Yeah.
Improves the quality of the end product. Uncover functional errors as well as architectural and component level design defects. Helps diagnose error. Simplify the correction by associating the test with incremental new build and rebuilds. Like they'll be every time they'll be sending it, and they'll be, if you are identifying something, they'll fixing it and they'll be giving to you. Like every new build, like if you're doing functional testing, component testing also, they'll be sending you, they'll be releasing a new build, right? That time you will be validating, and if you're sending it back to them if it is not stable. So one more testing is sanity testing. Even this sanity testing also you will be doing daily basis. So like as a QA, you want to change your career to QA. This is the one more keyword you will come across every day, daily day-to-day activity. Like, the main purpose of sanity testing is make sure that the proposed modifiers or functionalities works as intended. In few cases, like you're moving your code from dev to sit actually. Sorry, from one environment to another environment. You can say it as from test environment to you're moving to UAT. You'll be doing a sanity. Well, like sanity is like quick test. You'll be running like major functionalities are working fine or not. You will be doing a quick sanity test. Sanity testing is a type of regression testing used in quality assurance. If the sanity testing fails, the testing team rejects the software product to save the time and money. Like, see, it is also you need to understand the difference between sanity and the smoke testing. Sanity testing is like the major functionalities. Like suppose I give an example, you're moving the after you finish the testing, like the software is moving to the build is moving to one environment to other environment. Environment in the sense like test environment to UAT environment. You will be checking that the correctness of the application like by validating the major functionalities. Like you kind of regression you are doing here. Like the major functionalities are working fine or not, you will be validating. The build is deployed, all the features are deployed properly or not, you will be checking in that sanity testing.
So we'll be checking in sanity testing, we'll be checking software if it works in different environments.
Yeah, before like kind of like if you're handovering the product to one environment to other environment, right? So, yeah, one environment to other environment. Like you are otherwise like you are tested it. Usually, your managers or your team lead to say they'll say like run a quick sanity test to check the major functionalities are working fine or not. But in regression, what we'll do in regression, we'll be checking one or two test cases to whether we are able to proceed with our testing or not. But in sanity, we'll be checking the major functionalities. Like in sanity testing type of, it's a type of regression testing used in quality assurance. The main purpose of sanity testing is to make sure that the proposed modifications or functionalities working as intended. Like if you say like
Yeah, I understand.
when you should conduct a sanity, like when you will do a regression, whenever you get a new bill, you will be doing it regression, sorry, smoke testing, right? In the same way, when you will do sanity, bill is received from a number of regressions, or if there is any minor changes in the code. After bug fixes, the build is sent just before the production deployment. See, just before the production deployment, in the sense, like I said, right, one environment to other environment. Like you're moving the product from one environment to other environment. Like from your testing environment, you're moving to the UAT environment, or from UAT to it moving to the production. You'll be running this sanity, and you receive the
Okay,
number of,
I get it. I think. Yeah.
you raise the defect actually. In you find you performing testing, you find some defect, and you want to check like whether the functionality is working fine. See, the build is received after number of regressions. You perform multiple regressions, and or if there are any minor changes in the code, you suggested some minor changes in the code, minor changes. You'll be doing like it is not impacting anything, and you cross check that, like small minor changes they did actually. Some font or some button is not working, they change the button. So you feel like you will be validating that actually. You'll be validating that other functionality is not affected, or the major functionality is working fine. So you can move the code to next environment. You understand the major differences between
Yes.
test and sanity, right?
Yes.
In interview, whenever you are giving an interviews, right, they'll be asking this actually. These are common questions they will be asking. What is the difference between test and sanity?
Okay, so this, like, let me just make a note here.
Yeah. Benefits of sanity testing. Like we seen the benefits of smoke testing. What is the benefits of smoke testing? The same way you will be. What is the advantages of sanity testing? Is sanity testing aids the rapid detection of problems for fundamental functionalities. Like fundamental functionalities in the sense
major functionalities. Yeah.
Because no documentation is necessary for sanity testing, it may complete in less time. What you do is like you won't be executing any test cases or anything. So that is the reason it will complete in a less time. If you executing one by one, if you have some test cases, sanity test cases, you're running one by one, and your execution will be slow. But like quick sanity means you will be doing a regression without any documentation. Like you won't follow that execution process in this phase while you're performing sanity. Like you know the application, you did a multiple regressions, right? You know the complete flow of the application. You just open the application, you'll check the major functionalities directly without executing any test cases. Directly go and validate it randomly. I mean, you'll just play with the application. If your problems were discovered during the sanity testing, the project is rejected, which saves the time of regression testing. The team focus is on validating the application functionality rather through testing. Sanity testing is usually done on the build when the product deployment is required right away. Such for a criteria big bug patch, such as for a critical bug patch. Like if you see any, you find some defect in production, they are deploying it. Even that time also they will be doing this sanity testing as well. These are the benefits actually they mentioned. In like whenever any new bug is fixed, and you'll be validating that when it is moving to the higher environment. This is we have completed smoke testing and sanity testing. We move to test suite preparation. And I promise that I'll show you that test case and test plan template, right?
Yeah.
I'll quickly show you the test plan template, how it will be. Even I have to show you one more thing, that test plan and test strategy differences as well. I'll again, it depends. The test plan, see, components of a plan document, scope. These are the components of the test plan. Scope. What are the scope of your testing? Out of scope, like what are the what your like whatever you're not testing, you'll be mentioning here. Assumptions, like you'll be testing in this environment. You'll be, before starting with anything, you'll saying that assumptions, like known part, like everyone knows this. So I'll be testing based on it. All the conditions need to hold true for us uh, to be able to proceed successfully. Schedule, like when you are going to start, when you are going to complete, those things comes under scheduling. Test scenario preparation, test documentation, test execution, test cycle, start date and dates of the cycle, roles and responsibilities. I think this is not a better one. I'll definitely, by completing this module, right, I'll give you parallelly, I will take you to both test case writing as well as the test plan components. I'll provide you those documents. So yeah, that's one more thing. Basically, they will ask in interviews as well. So what are the components a test plan contains? Yes, yes. What are the components in test plan? What are the, what is the test plan template contains? So the first thing you have to understand is, like, here, from organization to organization, the test plan template will be varies. My organization goes and design some test template. Some other organization, they will go with some other format. So only
Yeah.
you have to consider that what are the major fields we'll be including in the test document. If you're providing a test plan document, what are the major keywords they will include? I mean, what are the different sessions they include? So those things, if you understand, it will be easy for you and it will be clear for you. If you go to any organization, you'll be clear on that.
Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.
Suit preparation is nothing but when you create a test case, right? The suit contains a multiple number of individual test cases together. We call it as a test suite. Like if you feel like some particular functionality, you can divide that into your test cases can divide it into some particular set. Like if it is.
So wait, test suite preparation. There's this test suite. It's a group of cases. So
Based
many test cases in one group.
The suite preparation involving construction and allocation of the test cases in some systematic way based on the specific testing technique used. For instance, when usage-based statistics testing is planned, test cases allocation will be defined by operational profile created as testing modules. When coverage-based testing is planned, specific coverage criteria could be detected by allocation of test cases. That's what they complete. Whole concept of test suit preparation is right. It is like when you doing any smoke test, right? Suppose you will be doing a smoke test. Either you will identify the smoke test criteria, like what are the test cases. You need to do it in while you need to run in smoke scripts. So you will keep that smoke scripts in one particular set. If you're doing a regression, right, you won't run all the test cases you won't run all the test cases. You just run particular test cases you will run only a set of test cases, not all the test cases. Those you will keep it as you identify all the test cases and you will make it as keep it as a regression test cases. You can say it as regression test suite. Test case allocation will be defined by operational profile created by the testing module. See here, when coverage-based testing is planned, specific coverage criteria could be detected. Allocation of test cases. Created test case. Operational. Created test scripts. Optional. Sorry. Add test scripts to the test case. Test to suit. Same thing like adding the test case to test plan. What happened is test lab you will be created test suit execution record, run the test suit execution record, analyze it. See it, again what they are doing is individual test cases, right? They're creating a test case. You're creating the test case. After creating the test case, you will be adding test case to a test plan. The individual test cases, add the test scripts to the test cases, create a test suite, add existing test cases to a test suite, create a test suite execution record. Generally, I said, right, based on the, based on the criteria, like which you're working, you can divide that test cases into particular number of test sets actually. So a suite is nothing but individual test cases. Only thing that when you run regression, you'll identify individual test cases which need to be run in the regression and you will be running it. When you're running smoke, you will be doing that. And in case of critical test cases, you can identify some critical test cases and you can identify them as critical test cases and you can separate them as a critical test case. It's all about test suite preparation. It again, you will be using some tools, right? Suppose if you're using ALM, suppose module wise, you can, if you're using tool ALM, HPALM, that is HPLM, application lifecycle model, that is. So what it contains a test plan, test lab and all. What you do is in test plan, you will be creating a suite and you will be adding all the test cases. In test lab, you will be adding all those test cases to the test cases in test lab and you will be executing it. That again depends which tool you are going to use. The basic idea is test suite preparation is identifying. You will be creating creating individual test cases and those test cases can be organized into some particular set based on the functionality. What do you retesting, right? Retesting is executing the previously failed test case against a new software to check if the problem is fixed or not. The defect has fixed. Retesting is performed to check the scenario under the same environmental conditions. During retesting, testers look for a granular details as the change area of functionality, whereas regression testing covers all the main functionalities to ensure that no functionalities are broken due to these changes. Generally, we'll talk about retesting and regression testing. Retesting is like whenever you raise a defect, suppose you find some defect. Suppose you find some defect. right? You will be
Yep.
you assign to me. So I fixed it, I assign back it to you. Okay. So what you do is you will be testing the failed scenario, right? Failed test case. So that is called retesting.
Mhm.
When any defect fixed and you will be testing that, that is called retesting. Suppose if you feel like the same environment, the same inputs, you will be testing that particular function, particular scenario. Functionality is failing in particular scenario. Suppose you logged in, you have a food app like what we are discussing earlier. If you have a food order app, there you logged in with some user role. Sorry, you logged in with your user ID, and you're trying to order some product. After adding to the cart, you seen that it was not product is not displaying the rate. So it's a defect. So you assign to me. So what I did, I fixed it, and now I assign you to back. What you do, you will do this. You will perform the same scenario, same steps in the same environment with the same steps, and you will check that whether now it is rate after adding to the cart the total rate summary is populating or not. You will be checking now.
Mhm.
So retesting the same functionality, it is called retesting. Revalidating the same scenario, same functionality for the functionality. It is called retesting. Regression testing is software testing practice that ensure application still functions as expected after any code changes or updates or improvements. Regression testing is responsible for the overall stability and functionality of existing feature. See, the main agenda of regression testing is if I fix that major change actually. If I now what I did, I fixed rate summary. Previously, rate is not populating after adding to the cart. Okay, so I fixed it now. So because of the fix, I need to see if I fixed it. Because of that, some other functionality got a defect now. It got affected. So like now it is continue to the payment button is not enabled because of that. So how can I find that? By doing regression. Like in or some other functions, some other because of this fix, some other functionality got impacted. So we can check it by using regression. There are different scenarios, like different situations when we can run a regression. Suppose first scenario is the major bug fixes has done. Suppose there is a major bug fix. Okay. So what you do is you will, after completion of testing, you will be running your regression to check that because of that fix, no other functionality got impacted. The system is working as smooth as earlier. And other
So you check, so in a regression testing, you check the software or the application if it works as good as before the bug fix,
that is the
after
first,
fixing the bug,
yeah,
right?
no, correct. That is the first scenario, the first situation. Like other one is like if some module is completed, I'm integrating some other module. Like suppose the login and adding to cart, I have implemented. Now what I did in second phase, I have implemented checkout and payment part. So I integrated with first functionality. So now complete flow is working fine now. So any new feature is added to the existing feature, you will be running the regression. So you check that like functionality is working as expected. Regression testing is responsible for overall stability and functionality of existing feature. See, when to apply regression? a new requirement added to the existing feature. What I said, if you already having some functionality and new functionality is added to the existing functionality. So a new requirement added to the existing feature. A new feature or functionality is added. Okay. And requirement is added like now what you do is suppose you have logged into the application and you have a restaurant one, right? You can now what you do, you can keep it as a restaurant as a favorite one. So it will be displayed on the top. Previously that requirement is not there. So you have added a new requirement to the existing feature. So in that case also you can do it in a regression. A new requirement is added to the existing feature. A new feature or functionality is added. The code base is fixed to solve the defect. See, when defects is fixed, we'll be running a regression testing. The source code is optimized to improve the performance. Suppose what they do, developers will fix the some code. They will optimize the code actually. Usually, what they'll do, like sometimes they feel like they'll remove unnecessary code and they'll optimize the code. Okay. So after that, they will ask us to run a regression to see whether because of the optimization are there new because of new changes in the code, functionality should not affect. In that case, also they'll say run a regression testing. Patch fixes are added, changes in the configuration. These are the scenarios they will ask us to do in a regression. Test automation is a necessary element in software development practice. Similarly, automated regression testing is also considered as critical puzzle piece. With rapid regression testing process, product team can receive more information feedback and respond instantly. Regression testing detects new defects, new bugs early in the development life cycle. So business does not have to invest in the cost and maintenance effect to resolve the build build up build up defects. Sometimes a seemingly mild modification might cause a domain effect or product key functionality. See, the main mode of anything, any functionality, like early finding defects, finding in early phase is better than finding the defects in later stage. Like later stage in the sense, once it move to the production, you find some defects. The cost of fixing the defect will be more than comparing to the earlier. Like
Right.
in your phase, like while you're testing, it will be easy for fixing the defect. Like when it is moved to the product, moved to the other environment, like higher environment, production or something. If they got some defect, there is a chances of like there will be more cost of fixing the defect and all. The maintenance wise, it will be not easy. And if you because of regression, you will find the uh, I mean because of the regression only you will find defects and all. Actually, if you are not running any regression, just you fixing and you are doing retesting, you won't come to know where because of that fix or because of newly added functionality or because of new requirement something got affected, you won't come to know. Again, if you are running it again, the regression test cases, you will come to know. Oh, because of this functionality, some other functionalities got affected. So we have to fix it again. Bug leakage. Like I said, like bug leakage is like when bug is detected, which should has to be detected in earlier build version of the application. That's what I said, right? We we find the defect, it will be more easy for them to fix the defect. A defect exists during testing at unfound by testers, which is eventually found by testers or end users, is also called as bug leakage. Right? If you're if you are not unfound, see here, a defect which exists during testing and we didn't find the defect. And eventually the found by the tester or end user. End user in the sense like while doing UAT or in a production. It is called bug leakage. test design is revolves around the tests themselves, including how many will need to be performed, test conditions, and the way the testing will approached. According to text design is, I can say in simple word, creating a writing test suite for testing software, but required specificity and detailed input. After choosing the input value, QA team can determine what expected result could be and documenting it as a part of test case. Doing so will help give the qualifications for the passing and failing the test case, allowing QA to quickly mitigate error and refine the projects to achieve overarching goals. Test design is you will be testing in some similar specified fashion. Like you will create some test case. So you have a login functionality. Suppose you will be creating a test case, right? You will be creating test case and you will be determining what is the expected result. What is the based on that, you will be passing a test case and you will be filling the test case. That is called tested design. You will be based on the functionalities, you will be designing that test case. What is the expected result and what will be the if it is error or if it is failed or it is pass. You will be deciding quickly. We can find the errors and all.
All right, let's test your knowledge. Here's a question for you. What document outlines the test objectives, resources, schedule, and activities? Option A, test case. Option B, test plan. Option C, test script. Option D, test log. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to become an expert in quality assurance? Our QA manual testing training course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about manual testing. It's like a toolkit for ensuring software quality, from finding bugs to ensuring everything works smoothly. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a QA manual testing pro? Sign up on our page now. For more info, check out ZaranTech's website.